What the hell was that?
I don't know, a bunch of fishies.
No, I heard like something, I don't know, something weird somewhere. Anyway, hi guys.
Hi, how's your hearing?
Yeah, that was pretty fucking professional.
I heard that. Was that your Mac informing you of a notification? Or
No,
I
I
don't
don't
know
know.
what that was.
I have no idea where that came from. It's almost like it came from my intro.
It came
video.
from God.
Tao?
It came from God.
Oh, Gao.
Which might also be Tao. Which might also be Tao.
The Gao. Okay.
It might be God.
Anyway, yeah, we're just production values on this channel are just going up by the minute. Fucking amazing.
Remember, Steed, we can never rule out the possibility of an intelligent agent sending that mysterious signal to the internals of the stream.
That's right. That was our one and only chance.
I know. That was Tech Jesus reaching out to us to save our souls from eternal computer chip frying.
Maybe we got hacked by Maddox and Socks.
Could
Maybe.
have.
I wouldn't be surprised if him being homeless now has encouraged him to learn how to hack computers.
Yep, he's probably read a huge wiki article on it or something.
You
Yeah,
never know what those rascally religious people are going to do in the name of Jesus.
The rascally. Okay, so I have we're going to talk about the paper Hot Springs hypothesis, and we've Scott found Bruce Dahmer's website, YouTube site, and we have a little short video talking about it, right? So I thought we'd play that first, and so we'll play this first and see what he has to say, and that may give us some background, which would be good because we need all the background help we can get, right?
This series went on a month's hiatus the series went on hiatus for a month, and I don't know why, but okay.
We were on a research sabbatical.
Was it really a month? Did a month pass?
It was pretty close. It was something like that. It was pretty close.
I blinked my eye and a month went by. Ooh, do you see what I did there?
Wow.
I blinked my eye and a month went by, and now I'm ready to die. Die.
Whoa.
Nice. Oh, that's pretty good. Okay, punk band, right? Right, Immutable? Die. Okay, I'm going to play this.
Some people think it started deep in the ocean. Others believe it was created by some higher being. And some even hypothesize that life started from outer space. What if, just maybe, the starting materials of life came from outer space, but instead of forming in the ocean, life started in hot springs? Shocking, I know. Life, even the simplest forms of life, are made up of complex proteins, which are long and complicated chains of amino acids stashed away in a barrier of lipids from the outside world. When we talk about the origin of life, at least from a chemical perspective, we are really discussing how we go from simple molecules like this to complex proteins, nucleic acids, and cell structures like this. We think that the starting materials meaning the amino acids and lipids, came from outer space. No, really, we mean it. It is one potential way that these building blocks of life got introduced to the Earth in the first place. Here's why. In 1969, a meteorite as old as the solar system, about 4.6 billion years old, came smashing down over the village of Murchison in southern Australia. Interested to find out what secrets meteorites contain, scientists at NASA Ames extracted samples of the meteorite and deciphered some of the chemicals within. As it turns out, it contains thousands of ancient organic compounds, including the amino acids and lipids, in large enough quantities, such that small bubble-like structures called vesicles form when astrobiologists like Professor Dave Deamer dissolve them in water. Of course, we are not discounting the possibility that some of these organic compounds could have spontaneously formed on Earth over billions of years. But from the Murchison meteorite, we know for sure that the starting materials of life, at least to some extent, did come from outer space. With some of the starting materials and vesicles at hand, how do we get from amino acids and nucleic acids to peptides and DNA? Peptides and DNA are essentially long chains of amino acids and nucleic acid, respectively, formed progressively when individual units.
It's paused.
We should pause and comment, otherwise it's not fair use, right? Or is that a problem? I don't know. Anyway, okay.
So far, this is a very good history lesson on what we know from the origin of life.
Yep. Yep. So should I kick it up a little bit?
No, it's soothing listening to his voice on normal speed.
Okay, we'll go.
Bits of these acids are energized and bond together. A simple wet and dry cycle, such as what can happen at the edge of a pond, which constantly gets wet and then dries back out again, has been demonstrated to sufficiently supply the energy required to create these bonds. Iterate multiple wet and dry cycles, and we have ourselves the foundation required for the simple amino acids and nucleic acids to bond repeatedly in order to form complex chains of peptides and DNA. The question, though, is where on Earth can we get naturally occurring wet and dry cycles to happen? This is where researchers, Professor Dave Deamer and Dr. Bruce Deamer from the University of California at Santa Cruz, proposed that hot springs, prevalent on Earth some 4 billion years ago during what's known as the Hadean Eon, is where the earliest forms of life developed. Keep in mind that Earth, 4 billion years ago, is very much unlike Earth today. The continents had not yet formed, and any dry land that existed probably came in the form of volcanic islands, like Hawaii is today. The hot springs constantly alternate between wet and dry, supplying the energy required for peptide and DNA bonds to form. Additionally, as the cycle alternates, the vesicles are constantly created and destroyed, much like how soap bubbles form when wet, but then get destroyed when dry. The brilliance behind this proposition is that this constant creation and destruction of new vesicles allows different combinations of peptides and DNA to form over the many cycles. Over extended periods of time and countless cycles, it becomes realistic to imagine that by chance, some combination of these peptides or DNA start to give rise to unique properties and possible biological-like activity, such as reproduction. Eventually, this might lead to something called a protocell, which is a primitive type of cell that originally arose for the evolution of modern-day biological cells. Thus, the researchers hypothesize that these cycles of wet and dry could have originally initiated Darwinian evolution, and eventually, life as we know it today. And this is why Professor Deamer and Dr. Deamer think life first began in hot springs. From simple amino acids and nucleic acids and lipids through countless cycles of wet and dry taking place at hot springs prevalent on Earth 4 billion years ago, to complex chains of DNA and proteins formed within vesicles called protocells. The paper we covered in this video is titled The Hot Spring Hypothesis for an Origin of Life by Bruce Deamer and David Deamer, published in the journal Astrobiology. Details of the paper can be found in the description below, and we encourage you to read the paper. Obviously, we can't cover the whole publication in a few minutes, but we hope you are intrigued enough to find out more.
I think there's a very subtle point of the video that needs to be emphasized more.
And what's that?
Which is much to the creationist dismay, Tangelo namely. You can't read a paper like extremely quickly.
Oh yeah.
When you cite a paper, it doesn't take a person like 5 minutes to read it. It takes like a few days to read it and understand it and soak in.
Yep.
Contrary to popular belief.
Yeah, much less to provide an adequate critique of it.
Yeah, so everybody should subscribe to that channel, by the way, seeing as how we're watching his content. And I did, but apparently it has not refreshed yet. Anyway, so here's his channel.
It's pretty cool.
At the Ram Dass Legacy Virtual. Oh, that looks cool. Okay, Engines, Burning Man.
He's also uploading some older presentations, like the one that said 2 days ago was, I think, from 2015.
Okay.
But yeah, they should be worth looking at. He's out on the field talking to people.
Yeah, he's got a bunch of content. Wow.
Science and spirituality.
He's also got some things on consciousness in there.
Oh my God. I've got to talk to this man. This is good. Okay. So we got that.
Yeah.
And I thought there was something else pertinent. And I know you guys love Maddox in socks.
Don't we ever?
But anyway, this is from Argotha, and I just wanted to point out his take on abiogenesis, which is pertinent, I think, before we get into the paper. If that's, let's see what we can do here. Maddox in socks. Okay. This one, share video. Okay, this is Argotha piping up. This is right after John Maddox said atheists are idiots because they think a can of paint can form naturally. So that was his example. That's a brilliant example he came up with is, do you think a can of paint, including the can form naturally, right? And then right after that, Argotha piped up.
I mean, that's one of the things is like the vacuum pump that James Stewart talks about. Like, where are you gonna get this process where you can freeze dry something? I don't know if it's in this episode, but there's one chemical where
the echo is on Maddox's channel, by the way.
You have to freeze dry something with a vacuum pump to get a specific process to occur, and then you have to put it in a centrifuge, and then you're like, well, okay, where'd they get that? Where was that on early Earth? How did it get transferred from this hypothetical vacuum pump to a centrifuge? And then it's heated to, 150 degrees for 10 minutes, and then it's cooled down to 60 degrees and stirred for 15 minutes, and then it's left to settle all these processes. You're like, how?
Okay, that's enough of that. But did you catch the gist of that? So where did this hypothetical vacuum pump on early Earth and the centrifuge come from? And he's pretty much quoting James Tour, who goes off on some synthetic process to produce one of these biochemicals, right? And anyway, that's what they got out of it. So they are so fucking brilliant.
It's just, I mean, it's almost like experimental methodology 101 basically kind of outright admits that the processes you use to design an experiment are not necessarily reflective of the way the dynamics of the experiment actually play out.
Yeah.
Right? But because they're simulated, they're kind of they're a good approximation. They're a good way of understanding kind of the core bits and pieces of what's needed.
Yeah, and it's usually as regards, I guess, abiogenesis and any process out in the wild. They're proofs of concept. You know, how could this possibly happen? Well, here's a possible way it could happen. The mechanic putting together the process, the pathway, aren't going to look like inside a lab.
I mean, the two questions Argoth are essentially asking is, how do things get cold, and how is it that something exists like in a vacuum or like without pressure? Well, there's a few places on Earth where there's not very high pressure, and those places happen to be pretty damn cold.
What kind of places what kind of pressure? Are you talking about air pressure?
Yeah, like the pressure of air.
Oh, okay, yeah. Very cold.
It's kind of like there's environments on Earth where conditions are quite extreme, and like things such as oxygen pressure and the pressure of air itself kind of vanish almost, or become very, very small, and it's like freezing cold.
Mm-hmm.
The point is that if you went out in the woods and there was a pond, and there was some sort of chemical product being created in that pond at a very low concentration, and you wanted to figure out how that chemical product got created in that pond, okay, you would not take that pond or presume to take that pond and put it into your laboratory and then just watch the pond do exactly what it just did, right?
No.
What you need to do is you need to know everything that is happening in that pond. And in order to do that, you'd have a hypothesis that these are the starting materials and, okay, this is the product. And then you would run a very, very strict laboratory experiment with very clean products and clean, pure compounds to figure out whether or not that reaction could happen at that particular temperature range and in some environment, but you're looking at a particular part of it. Well, then if you wanted to go check out the other new chemical in the pond, you would run a different set of experiments. You come up with a hypothesis. At no point could you set up some sort of crazy pudding type reaction with a whole bunch of dirty chemicals in it and dirty equipment, and then hope to get a yield that's great enough for you to stop in intermediate steps and determine what's happening. So, I mean, this is just how fucking science does it, right?
Let's go with a different example, right? Hopefully we've all seen trees, and Maddox, if you haven't seen trees in a while, go out and see some. They're kind of magical. I mean, suppose we walk outside and we see a tree that's fallen, right? Not exactly an unusual occurrence. It happens now and then. And so, as people that are curious and want to find out things, we want to figure out, okay, how the hell did this tree fall? So you might begin tussling the tree and, seeing if there's any incisions in the tree that indicate that it might have been cut over or stuff like that, and try to piece together different variables that may indicate that this tree was about to fall over, right? Maybe there's some rotting on certain parts of the tree that made it susceptible. But the point is, right, if we're interested in making predictions or experiments about how this tree fell, there's ways we can mirror that, right? We can set up wood slabs or things that are similar to trees and experiment. Like what kinds of cuts or incisions in the tree, would make it fall in the way that we first observed it when we saw it that it had fallen to the ground, right? Where the creationists are saying, oh no, to know how the tree fell, you have to know everything that happened in the tree right before, up until the moment the tree fucking fell, to understand how the tree truly fell to the ground, right? Otherwise, the conditions you're positing are just asinine and ridiculous.
Well, let me belabor this point, okay? If I wanted to find out, if I wanted to find out what happened in one leaf of that tree, if I wanted to know how some step in photosynthesis happened, just one step, I would take a few thousand pounds of leaves, I would squash them up, I would run them through a centrifuge, and I would purify them and filter them, and then I would run it. Then there'd be some chromatography, and then we'd get the layers out. We'd be looking for one specific enzyme, and when we found that one specific enzyme, we might hook up a radioactive marker to it, right? And then we get another specific enzyme at great purity, right? And we combine them, and we find out if our hypothesis works. If we can go from point A to point B, then we go back to the leaf and we do it again until we figure the whole damn thing out. That's how they found out about photosynthesis. They didn't do it by going out and staring at a leaf, right?
I mean, part of it too is you have to consider, and this is true for any field of study dealing with reconstruction or trying to make predictions, which is what science does, but it's also what fields of forensics does. You have to be very strict, and you have to be very very precise in the type of environment you study. Why? Isn't that cheating? Isn't that being oversimplistic? No, because remember, the world, I know it's a weird concept. The world is complicated, right? There are a lot of things happening in the world. There are a lot of things to keep track of, and a lot of things that can divert our attention. And so to test if a variable produces the result we expect to see, well, you better control for that variable. You better design an experiment to see, okay, if I increase the concentration of the chlorophyll or this compound that participates in the photosynthesis pathway, does this influence the activity? If so, yes. If no, okay, why? Why not? Right? There has to be controlled settings to understand these very complex phenomenon. And once we have more pieces of the puzzle, then we can do things like simulation. We can begin trying to think about environments, for instance, such as, okay, now if I know that this compound reacts with this other compound, and this other compound reacts with this third compound, and yada, 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 and this first reaction takes place in this environment, and this other reaction takes place in yada, yada, yada. Okay, great. Now, can we make sense of that information? Can we put that into a toy model? Can we program this in some type of way that we could try to see the effects of these processes in real time? What do we expect them to produce? And then experimentally, perhaps we can try to mimic that. And the way we mimic that is, okay, we obviously can't get the dynamics of a volcanic site down perfectly, but we might be able to get some of the core essentials down. We might be able to get the heating and the rotation and the cooling and the raining and precipitation parts down. So let's see if we can design an apparatus to do that. And once we've done that, let's see how well our simulation matches our toy model of this kind of mimicking environment of the real one.
Yeah.
And if it's accurate, right, hopefully we should get products that we expected to see in the simulation as well, right? And hopefully in similar proportions. But if not, then it doesn't mean we just give up and pack up our bags. It means, okay, I didn't understand the photosynthesis correctly, or there was some aspect of my formulation that went incorrectly. So let me tamper with some of the variables, or let me think about this process more carefully to see how I can, what new variables or how I need to adjust the variables to accommodate the result I've seen.
Yeah. This quote that Jerry Pena put up from the email, I think I actually saw that quote. So ABio is exploding with new discoveries and approaches. And this is from somebody who actually works in the field, unlike these other, I don't know what to call them, who do not work in the field.
Pseudo-savants.
Bob Agatha. Where did the centrifuge come from in prebiotic Earth? What a brilliant man.
I'm honestly surprised he can spell or say centrifuge.
Sometimes he seems, pretty intelligent, but then when he talks about science, not so much.
God help you. God help you if you mention the word Jesus to him.
Jesus Christ. Okay, so
he just loses his mind.
Somebody want to read a paper? So we're on section 3 of the paper, and we haven't done anything for a few months or a few weeks because we have been researching, right?
Yeah, we've been on sabbatical researching.
Research. It's
one of those research sabbaticals. You know how it is.
Yep. Okay, so this is kind of the point of section 3. If somebody wants to read it, somebody who can pronounce stuff.
I guess I'll give it a try. Since y'all let your vocal cords go to rest. Here's a nice quote from Eigen. That's Igor's brother. We may envisage that such a process of molecular self-organization includes many random events which do not have any instructed functional significance. What really matters is how certain such random effects are able to feed back to their origin and thus become themselves the cause of some amplified action. So we're looking for feedback and loops of feedback. Section 2 laid the foundation of experimental and observational results and their significance. Section 3 is necessarily speculative because a freshwater origin has implications that have not been previously explored. So those of you who say, gosh, this sounds too speculative, well, you're right. It's not true speculative, but it is speculative. The above quote from Eigen proposed the emergence from a random background of functional molecular systems able to amplify some action and by implication their own continued presence. We have proposed that such a system can start before the existence of genes through simple effects such as protocell stabilization. That's an important point right there. The early part of the scenario relies on a form of phenotypic inheritance similar to the compositional genome, described by Segre et al., in which properties are inherited according to their composition rather than information stored in a polymer sequence.
Okay, so the 2 points here, the main point is that freshwater origins have kind of been or not well explored in the field. And I believe that is something that Deamer is also working on, is the freshwater possibilities. And that's something sort of new, the last 10 years, whatever, maybe not so much. Now, the compositional genome described by Segre.
That's what I'm going with.
Segre, I guess.
Segre. Okay, by Segre. Anyway, so the idea here is that there is a composition, and that's where the information is, in the composition of the mass inside of maybe inside of a lipid membrane, rather than informational from RNA or DNA. So the information would be in the composition. And I haven't looked at this paper. I don't know why I didn't pull that one up.
But also keep in mind. But also keep in mind what it also said, right? That the information, and this is Demeter's point, that the information also has pertinence to its environment as well, right? There is no information without the environment,
right?
And that's a central point that's kind of really needs to be hit home.
Yep. Okay, so now we're moving to a different page, and I have to do this thingy here. Doing my thingy. Okay, did my
Thing.
Okay.
What are the heritable properties of protocells capable of surviving successive cycles? These properties must emerge from a synergy between the components of the system, which are the polymers and the surrounding membrane. All of the processes up to this point have been driven by self-assembly and a very simple source of energy, the chemical potential of dehydration that drives ester and peptide bond synthesis so that monomers can form polymers.
That's actually a very important point, right? And part of the important point is in one of Deamer's videos, but to kind of summarize it, is that look, esters and peptide bonds are things that are essential for life to get on the ground. Esters aren't that hard to form chemically, but peptide bonds specifically, right? The way amino acids react into forming peptides is two amino acids will react with each other, and you have so what is an amino acid, right? So it's a compound that has an amine group and it has a carboxyl group, so a C double bond OH. Well, what happens when two amino acids react? Well, it forms a peptide bond, and one of the products of that is water. So this process wants to favor water, and one of the points I think the paper will make, and if it doesn't, Deamer makes this point explicitly within some of his talks, that look, if you're in an environment like with a hydrothermal vent or something like that, where there's tons of water, you're in an ocean, how are you going to encourage this type of bond to be formed, right? How do you create something that's wanting to release water to its environment, pushing more water to the environment when there's already enough water that's saturating the environment, right? And this is also one of the advantages of the hot spring hypothesis, is that look, one of the central points is that it's revolving around these wet dry cycles, and the dry cycles, particularly when there's not much water, when this water has been absorbed onto clays or other things, that's when these peptides would be susceptible to form, because the process of water can form in that place, right? Because the environment isn't saturated with water.
Yep.
Go ahead.
Let's see. Where did we stop?
The prebiotic synthesis.
Right under the highlight, the second highlight.
Okay. The prebiotic synthesis of nucleic acids must have been non-enzymatic and would lead to complex mixtures of variable length strands having random sequences of nucleotides. How can these possibly begin to incorporate catalytic functions? One answer is found in CELEX, the systematic evolution of ligands by exponential enrichment. They've got an acronym for everything. An experimental procedure that allows extraction of oligomers with a desired binding affinity for a given molecular target from an initially random pool of oligonucleotides.
Okay,
Evolution.
Foreskin.
What? Foreskin? Okay.
Foreskin. Oh, can we foreskin the reading of a document?
Apparently, because I stopped.
Oh, okay. Anyway, I want to point out that this is, let's see, variable length strands of random sequences of nucleotides, and that's very much in Demeter's area. Okay.
Yeah, that's one of the things he also posits with, I forget the particular name of it, but for how his peptides form.
Yep, he fits in very well with this theory. So anyway. Okay, go on. I'm sorry.
Okay, so I said oligonucleotides one more time. Evolution of catalytic RNA from mixtures of random sequences was demonstrated by Bartel and Sozak and Horning and Joyce. But these were laboratory experiments using purified nucleoside triphosphates as a source of energy, and the reactions were catalyzed by multiple enzymes. It is possible, however, that similar selective processes could have discovered catalytic functions within vast numbers of self-assembled, encapsulated random polymers on the prebiotic Earth. What is needed now is a similar demonstration that systems of encapsulated polymers can also evolve useful functions such as pore formation and a primitive metabolism that supports growth by catalyzing the formation of copies of additional useful polymers. The following discussion describes what we believe could be a fruitful direction for future research.
Okay.
Walker et al. Used computer models to show how sequences of functional polymers can become established in a pre-existing pool of non-functional sequences and monomers. We developed this further by proposing a mechanism for the emergence of specific functional polymers by cycles that incorporate a kinetic trap described in section 2. Cycling encapsulated polymers promotes selection between molecular systems at the level of the protocell while reducing loss of products due to diffusion. The system that would emerge through such a large number of natural combinatorial experiments could plausibly evolve the structures and functions necessary for the transition to cellular life. Returning to the computing metaphor for the origin of life, and notice it says metaphor.
Yeah, I know. It's almost like there's a way of picturing this for an audience to understand.
Yeah, it's almost like he anticipates hyperliteral
interpretations of this piece.
There is another concept that is useful. The bootstrap. Now, tie yourself down. Now, don't get excited. The bootstrap idea is pretty cool.
Oh, now we're going to talk about computers.
A bootstrap is an initial small program loaded by a computer, which when executed activates hardware that loads subsequent programs. Those programs in turn begin to start up services and peripherals such as a network or data stores. The programs must establish a handshake that is coordinated by shared messages. Hey, I need a bigger journal there.
What the hell just happened?
I don't know.
I didn't touch anything. Okay.
Sure.
I do shit.
The emergence of large numbers of simple protocells housing random sets of polymers that assemble in a cycling pool provides an opportunity for one to be selected as a bootstrap. The criterion for that first bootstrap is simple, that the polymers contained within the membrane-bound compartment act in concert with the membrane itself to stabilize the system and prevent the loss of polymers due to hydrolytic effects or dispersion into the surrounding bulk solution. Therefore, the first selective factor is that protocells are stabilized long enough to return their cargoes into subsequent cycles of synthesis and testing.
Commercial break. Commercial's over.
The stabilizing polymers are analogous to the cytoskeletal proteins that strengthen the membranes of living cells. We refer to these as polymers and propose that they constitute the earliest bootstrap for life. That was very wisely highlighted before we started this program. With the S polymers present, the stabilized system of encapsulated polymers is maintained and provides the platform of a kinetic trap so that other functional polymers can emerge. A second essential function of polymers in the earliest step towards life would be a pore formation in boundary membranes that to have access to potential nutrients available in the surrounding medium. Living cells today have evolved enzymes and channels that transport nutrients and maintain ion concentration gradients, but much simpler peptides can also produce pores. One example is the antibiotic peptide gramicidin, composed of just 15 amino acids.
Okay, hang on a second here. Now that's pretty small. That's pretty small, 15 amino acids. And I have not looked into this. We could look into this. We could, divert away and look into it. But this is kind of cool because there's a very, very small, small peptide polypeptide that does this function, which is kind of amazing. It has an effect on these lipid membranes. And this is one of the things that they have pushed back against.
Yeah, and the thing is, like, what you're looking for is you're not looking for a full-blown protein. You're looking for small little peptides that can kind of essentially jam themselves into parts of the membrane and stabilize it, right? So that, like it was saying,
and so that hydrophobic.
Yeah, so that this little lipid membrane has enough time to survive, and that other lipid membranes that are less fortunate will just, disintegrate and release their cargo back into, back into the environment, thus, completing one round of replication.
And alpha helices of 22 amino acids are big enough to punch through a membrane. So basically, if you have a, it doesn't. I think it has to be. Well, if there's more than one, but anyway, hydrophobic alpha helix of 22 amino acids can traverse the membranes, these lipid membranes, and they tend to do so pretty easily. And if they have further amino acids on the outside that are hydrophilic, there would be some function. But then if you have two of them, there's a possibility that the, let's see, there are some hydrophobic or hydrophilic parts in the middle that will create sort of a primitive membrane channel. So, I mean, there's all sorts of chemistry that has to be acknowledged here with very small peptides. Okay.
Yeah. I mean, what you can consider in that case to kind of simplify it for the audience is, look, you might have like a very small little chain of amino acids, maybe 20 or 25, right? That's about on the scale. And hey, one of those amino acids might have a composition that enables it to kind of jam itself in the middle of this hydrophobic membrane, given that the content of the alpha helix is sufficient. And the thing is too is like, look, if you can join these peptides, if you have multiple peptides that are interacting or perhaps linked together, well, what does that do? Well, some of the regions in the inner space of that helix, right, might form essentially little pockets, might form little holes that are permeable to only specific types of ions. And that might act as a filter in some way so that ions like sodium and calcium and potassium or things like that, so that only ions of a certain diameter, of a certain kind of thickness, are able to pass through and not others.
Yeah, but apparently gramicidin can do it very simply. It's a small. It looks like it's an A head-to-head dimer. Interesting. We'll have to look at that after because they have a nice, interesting rotating model here in the Wikipedia, actually. So I'll link that in the chat so people can look at it.
The point of that is just to establish, look, you don't need huge things to get big effects. In this case, they're just showing an example of 15 of a peptide that's 15 amino acids long. That's remarkably short, right? That's about like a tenth or a seventh of the size that most proteins normally are at, which is usually like 200 to 200 to 300 or something like that.
Can I bring up what this has popping in my head is how complicated or how complex, that's the same thing, I'm sorry, how big would Luca have to be to be the ancestor of all the populations of life that we see today? It wouldn't have to be that much, would it?
The thing is, like, from what they're postulating, it wouldn't need very many things at all. Because what it would need, essentially, is it would need the ability to metabolize things. It would need the ability to preserve its own cellular structure. And that also includes kind of like inheritance of information. And, it also needs to be able to kind of extract materials from its environment and to create things that it needs from it. So probably not very complex, not with respect to how complex life is nowadays.
And look at the structure of that thing. I think it's an alpha helix, and it has glycine, alanine, leucine, alanine, valine. I don't think these are. I think those are some of the earliest amino acids. I'm not sure about tryptophan, but
I mean,
the other
is
one,
like look at the core sequence of that, right? I mean, it's glycine, alanine, leucine, glycine, alanine. You know, these are very, very small amino acids. So they're very abundant on the early Earth, especially from things that Deamer was mentioning earlier, like the Murchison meteorite. The majority of amino acids that were present on that meteorite, when analyzed, turned out to be glycine and alanine, and a few other amino acids, but mostly glycine and alanine.
yeah.
So these aren't very complicated amino acids, and they would have been in sufficient concentrations to to have been incorporated into a small little peptide like that.
Yeah, and Bacillus brevis still has them. It still uses them basically as a weaponized protein to fight other bacteria, apparently. But anyway, back to the paper. The point was that they let's see if I can get back to the paper. They allow sodium and potassium to pass through the membrane, which is interesting. Then if we have some sort of a gradient, let's see, application window. I'll go back to paper. Okay, we're back. Where were we?
I guess when added.
Or Gramicidin, rather.
Okay,
Yeah,
go ahead and read. Yep.
When added to membrane-bounded vesicles called liposomes, gramicidin partitions into the lipid bilayers, and two molecules assemble into transient transmembrane channels capable of transporting sodium and potassium ions.
Brains.
Pore formation in protocells is important for two reasons. First, the pores allow nutrient solutes to diffuse into the intracellular volume so that primitive metabolism can be supported. They also have a protective function by allowing ionic solutions to equilibrate across the membrane. As evaporation occurs during a wet-dry cycle, the initial modest concentrations of the various ionic solutes of hydrothermal fields increase 100-fold or more as most of the water is lost to the atmosphere. When fresh water returns, a large osmotic gradient develops that can cause membranous compartments to swell in volume and release encapsulated components. Selectively permeable protocells can survive into future generations because pores permit equilibration of otherwise destructive osmotic gradients. I swear I have not been drinking alcohol.
We believe you. We totally believe God.
You believe me? Okay. An interesting corollary is that protocells able to survive the osmotic effects of wet-dry cycles will be pre-adapted to the stresses they experience later in salty seawater.
Okay, hang on a second.
Okay.
Right there. I mentioned that earlier, that there's this complaint about seawater, and this is one way in which these cells can survive and basically equilibrate or whatever, or change their composition in seawater. So
usually it's pronounced equilibrate.
Equilibrate. Yeah, I'm so used to the equilibrium, that word, that it messes me up.
Equilibrate. Yeah. Okay. Anyway, I just wanted to point that out. And I think, let's see, I actually have the paper by Saha, but we can look at that later. But go ahead.
The same pores that emit.
Well, I'm sorry.
That's fine. Just don't move it. The same pores that ameliorate osmotic stress will also permit increasingly concentrated nutrients to enter protocells during a dry down. Nutrients combined with sources of energy entering the crowded interiors of aggregated protocells in the gel phase set up the possibility for the emergence of autocatalyzed metabolic cycles.
Yep.
And there's the quote. There's the reference. The above scenario provides a platform available to experimental testing. Indeed, the first steps of the scenario have been confirmed. The stabilizing effect of initially random polymers on protocells allows elongation and potential amplification of those polymers. Reference, reference, reference. While the emergence of pores or metabolic cycles has not yet been demonstrated, pore-forming polymers could be observed in future experiments carried out through multiple cycles under a number of conditions. In fact, Vlasov demonstrated that selection and amplification of certain RNA species lead to ion-conducting defects in lipid bilayers. Because protocells with encapsulated polymers vary in size, composition, and contents, a natural version of combinatorial chemistry becomes possible in which each protocell can be considered to be an experiment in which relatively stable molecular systems will be preferentially selected as suggested by Adamala and Zostak. Let me make a quick point here. We've read several complicated declarative sentences here, at the end of which are references. These are assertions. To have an assertion is not a bad thing. In fact, Otangelo the other day, and I forget in what context, said that the reason why he just reads the abstract is because everything in the middle are assertions.
Right.
But these are not what you call bare assertions. A bare assertion does not reference any facts or any
papers.
Any what?
Any papers.
Or any papers that support what you're saying. But if there is support there, that is an assertion. That assertion can be wrong. That assertion can be right. The point is it supported? And that's why we read the middle, folks.
Yep.
If you're not reading the middle, you're not really drawing proper conclusions, most likely. Now, you can read the abstract if you don't have time, so you can kind of get the gist of what the paper's about. But don't dismiss the middle part of a paper because it makes assertions.
Yeah. I mean, here's the thing too. Like, when I speak with you and Speed and any other person for that matter, right? I make assertions implicitly in regards to the fact that when I speak to you, that you guys exist, that you guys have a sufficient understanding of the words and the way I'm using those words and sentences, such that we can communicate properly. There's an endless number of assertions that are created, right? And assertions aren't necessarily a bad thing. But what a bad assertion is, what Otangelo is trying to highlight, is essentially that, hey, look, you guys are asserting things without any rationale. And no, that's far from true, right?
Yeah.
If you go to the reference page, and even with this, even to this paper, right? What's the reason the parentheses exist and you see those authors is because these claims, these assertions, if you want to call it that, being made by the authors, they are citing sources in which these assertions have been, to some extent, justified by experimentation and experimental methodology, right?
And there are 5 papers of references at the end of this paper.
Yeah. So
five pages, yeah.
So while it is an assertion, right, it is at the very least a grounded assertion. It is an assertion that has been made in favor and by virtue of examining the evidence and seeing, okay, is this assertion that we're making, is this claim that we're about to make, has it been tested before, right? Are there sufficient reasons that we should believe this is true based on the preponderance of data that currently exists?
Yeah. I think there are over 200 references at the end of this paper. So,
and honestly, right, you should expect no less from a paper like this, right? Because this paper is very ambitious in what it's claiming, and especially in the idea that it's proposing that freshwater environments seem to be a plausible candidate, if not more plausible, than hydrothermal vents, right? That is a very strong claim for a paper to make indeed. And if you're going to make that type of claim, you better be able to back it up, right? There better be something you have to bring to the table And your model needs to be able to be tested and explain the same things that this current model already does. So yeah, I mean, it's very good that this paper has so many references to it.
Icarus going to get blocked again for saying things about Otangelo.
Oh
Anyway.
no.
Yep.
Otangelo is special. You can't beat up on him too much.
Yeah. So I think we're on the next
I
page.
think I'll go. Yeah. Do you want to read speed?
I don't. My
You
mouth
don't?
is full of cotton tonight. Could you read, please?
Okay. Well, I guess I'll leave some for you. Selection and evolution of functional polymers. Laboratory studies of mononucleotide polymerization have shown that each wet-dry cycle yields polymeric products in the range of several percent of the monomers present, and these become encapsulated in lipid vesicles. We are not specifying their composition, but if the solutes include monomers such as nucleotides and amino acids, the polymers would resemble RNA and peptides. As well as possible complexes of RNA with peptides. That sounds very similar to Deamer's model.
Deamer. Yeah.
It is not difficult to guess what the additional functional properties of the polymers will be, because through hindsight, they would be precursors to functional polymers in cells today. However, what order of emergence might these polymers take? Figure 6 summarizes the stepwise emergence of functions. The text across the top indicates a proposed order of emergence, with a purely physical property of stabilization being the initial bootstrap, followed by pore formation, P, metabolic cycles, M, which then provide a platform for a replicator, R, ability to use a catalyst, C. At some point, a feedback function, F, which that feedback function would be the environment, emerges to control the rates of these reactions. Inset A depicts a cartoon representation of a model protocell having S, P, M, and R functions operating in tandem. Inset B illustrates how protocells containing random sets of these polymers bought off from lamella during rehydration. The budding process acts as a natural mechanism for protocell reproductive function, R. Selective pressures acting on the population through the three coupled phases would select for the most general stabilizing factors. And so protocells, with more functions working in tandem, are likely to emerge and establish coherent sets of functional polymers.
Are you reading from the screen, or have you gotten ahead of me?
I'm reading on the screen.
Oh, you are reading? Okay. Was that the end of it? Because I got lost.
There's one more sentence.
Oh, I'm sorry.
Bottom of the page.
I'm a bad person. Okay.
Not shown, but implied is an informational I.
Where's that? Oh, okay.
Yeah.
You ready?
Yeah. Not shown, but is an implied informational I polymer that enables the replication of specific sets of functional polymers, which, when it first emerges and how it operates, are subject to speculation. But perhaps it begins as a template-based system. Finally, inset C shows, clockwise, a protocell with all functions SPM RC under the control feedback F, and then collectively operated on by a set of D polymers able to duplicate minimally viable sets of functional polymers. By minimally viable, we mean that when another D polymer enables the division of protocells in two daughter compartments, they are viable and able to grow and divide again. The division marks the transition to lines of living cells. The D polymer enables division. The D polymer enabling division may have resembled a primitive version of the FTS Z protein that forms a contractile ring for cell division in bacteria. In summary, the above scenario steps beyond serial approaches to the origin of life, sometimes characterized as metabolism first or genetics first, by proposing a complex mixture in which both metabolic and genetic functions co-emerge with a cycling, lipid-encapsulating polymolecular system.
Oh, damn it. You guys read it all, and now there's nothing for me to read.
Oh,
So,
darn.
There's a... Oh, you're going back, or...
Huh?
Are you doing section 4? Because I'm just getting warmed up now, or...
No, you don't. You want to slow your goddamn roll.
We just we've taken like a month of breaks, and maybe we should entertain the audience.
We are entertaining the audience by actually talking about this diagram.
Audience,
Yeah.
are you not entertained?
But
Sorry,
yeah,
that was
audience.
Gladiator.
So I'm hoping you can see this diagram. I really wish I could get rid of those things on the left, but let's see here. Cartoon representation of the emergence of functions within cycling protocell populations. The top of the figure represents a simplified order of emergence of these functions. So we have stability, pore forming, metabolism, and replicator. I believe that's AB. No, that's just ABC. Okay, so figure A is a model of the early protocell with S stabilizing factors and P pore forming polymers. So that's the first part. And let's see. At some point, polymers that can function as catalysts must emerge. And the two illustrated here are metabolic, capable of catalyzing growth, and are self-replication. So figure B represents budding protocells capturing various combinations of these polymers. So budding protocells, that's interesting. So here's your lamella in your wet-dry cycles. You know, they form these lamella, if I'm saying that right, and then they can bud off into, you know, possible protocells. And here we have that compositional information. The composition of each cell is what the information consists of, right?
Mm-hmm.
And then what do we got here? Let's see, capable of function, capital. Okay, I reread that. Which affect their survivability. Okay, C is an abstract representation of a protocell containing a more evolved system of growing polymers controlled by feedback networks F. So there's your feedback networks up there. I don't know if you can see my cursor or not. Can you see my cursor?
Yeah.
No, you can't on this thing, can you? Can you?
No, I can't.
No, you can't.
It drops in and out. It just depends.
Yeah, that's weird. Anyway, let's see. Feedback network. This system triggers a polymer mechanism, D, that can duplicate minimally viable sets of these polymers and deliver them back by division into daughter cells. If these daughter cells contain fully functional polymer systems and are able to grow and divide again, they form the first lines of living cells. So when these micelles or protocells, when they, like, if something is creating the membrane itself, it will eventually get big enough to divide, and then it divides into two different cells. And by happenstance or genetic drift of this compositional information, that's where, you know, the possibility of a speciation event, right? So like every time they divide, there would be some minor difference between the cells and possibly a lot of similarity. So what we're looking for is this system, you know, at a very simple level.
Yeah,
So,
I mean, what you're looking for is what the paper is essentially saying, right? You're looking for a system that, number one, you know, it has these processes named above that's stabilizing, that's replicating, and that's metabolizing, which aren't too hard to pull off in a very primitive way. You have that it's budding off by some physical process, more than likely. And then you have this kind of game where these little protocells or pre-protocells, however you want to think of it, go off into the environment, and they, you know, are subjected to the harsh world of the environment. And the ones that survive do, and the one that don't, you know, continue on. And there's some feedback mechanism, you know, by the environment and fluctuations within that environment based on mineral composition and all sorts of other stuff.
Yep. And just, I don't know, I just pulled up a few of the papers that were linked, and one of them was this one, Saha, that was linked pretty early. And I got to make that a little bit bigger, don't I? Oh, but if I make it bigger, it gets all funky. Okay. So molecular crowding and early evolution. The environment of protocells might have been crowded with small molecules and functional non-specific polymers, in addition to altering conformational equilibria. affecting reaction rates and changing the structure and activity of water. Crowding might have enhanced the capabilities of protocells for evolutionary innovation through the creation of extended neutral networks in the fitness landscape. So neutral networks, I believe, were referring to Kimura's. I consider the neutral theory to be the what was it? Not the junkyard, but the machine shop, basically, of or the what the hell was it? Basically, a shop with a whole bunch of stuff laying around in it, and eventually, when you stumble in there to do something, you'll find what you need to do. What you need to do, and that's kind of what this crowding thing is about. And that's where I got the
workshop is a perfect.
Yeah, it's a workshop. Rather than junk DNA, it's workshop DNA is what I call it. So workshop DNA, and that's neutral. Yep. And this is where I got the illustration for the icon for the show from this paper.
That's a pretty cool looking icon.
It is a pretty cool looking icon.
Cool.
Current environment of the protocell. The ribozymes red are encapsulated in a fatty acid vesicle that is crowded by various prebiotic polymers and subcellular structures. Elements of this illustration are not drawn to scale. I think that's a disclaimer. And this is the fitness landscape, I think, showing the. Yep. And let's see.
Who did I watch that showed a similar diagram of a fitness landscape? I think it was that guy John from Stated Casually in that coelacanth video.
Yeah.
That was a good drawing.
Fitness landscapes are kind of cool. As the environment changes, the fitness landscape will change. And if they match up, if the two coincide at some point, then you have fitness success, right? So I've got to put these paper names in my description so people can look them up. And if you Google them, you'll find the paper right away. So I'm not going to.
Speaking of papers and stuff, I was looking for the information about impact, I guess, of a paper. Is there one place you can go and enter a paper's name and it will tell you the impact, like number of citations and things like that?
Does Scholar do that, or does those other sites we looked at Immutable?
I thought it did, but for some reason I couldn't find it. So
sometimes, although not always the case, because there's a few hidden gems in Google Scholar. Like the citation index usually is a good measure. Like Demeter's paper, I think. Let me see. Let's look it up. Demeter.
Keep saying his name, maybe he'll join us.
I know. All I gotta do now is say Beetlejuice several times.
Or 11th Dimension.
I know.
I'm trying to find where I put those other sites that we were looking for papers.
So does anybody know the story behind Demeter's handle there, 11th Dimension? Why he decided to choose that one?
It's in reference to string theory.
Yep.
String theory? Okay.
Okay, so here is a search site. I'm going to put it in public chat. And I'm looking for origin of life on this thing because that's what Immutable and I were looking at. And so it'll pop up papers, and let me see. This is kind of nice because you can download a CSV file. They have a lot of free downloads on this site, by the way. And let's take a look at it.
You had me at free.
Had you at free. Let's see here. So paper trail, search results. Cool.
Ooh, BrainBug. Here's one on the Cambrian explosion.
Okay. Goddamn cat. So these are cats and raccoons. I'm telling you. One day you're going to find just my skeleton. Okay, guys. So this is a really good site. It's Springer. And you can actually download, like you can search. I forget how we downloaded. How did we download? So you have conference paper, reference works. It breaks them up. Does it give you the impact or any of the relevance? Not sure. Language. I don't know if you can get that information off these things. Well, let's see. Relevance, news first. What are all the options? A whole bunch of search options here. One of them, though, is where do we download Mutable? You can actually download a CSV file of all these papers with their with the URLs.
Really?
To link to them. Yeah, remember we did that together actually about 3 months ago when we started searching for ABio papers. We went to this.
This will be a part of the paper. This will be part of the. This will be part of the thing that goes off of YouTube. I don't think we should be encouraging people to develop bots that scrape Google Scholar.
No, this is actually legitimate. You can download the CS somewhere down here. You can download all these things, legal information, and these are all free. You can download the PDFs of a lot of these papers, and this is
now.
Not all of them are downloadable free, but I'm finding that on this site, like 80% of these ABio papers are available to the public. So,
anyway,
nice. This is Springer Link. This is where the papers get published. So, review your search. Okay, here we go. Download. So, I believe, yeah, if you hit that button, my Google Chrome for some reason has. Oh, I don't know what happened there. Google Chrome for some reason is screwing me on this, but anyway, you hit that download button and you can download a comma separated value file you put in a spreadsheet and accumulate all these papers, which is what we wrote software to do on Google Scholar, right?
Yeah.
Oh no, yeah. And Google Scholar got very mad at us because we visited 140 pages in one day.
Something like that.
They said no more. We know you're not reading all those papers, John Maddox.
we know they feared we were mirroring Otangelo's activity and decided to cut us off when they had the chance to.
Right. So okay, Original Life, and I don't know. Did we have problems with narrowing down dates and things like that? But anyway, this is a really good site, and I linked it in chat, and everybody should take a look. And we found what did we find? 10,000 papers in 10 years or something. Something in that order.
Something
My
like
cats
that.
are
Usually within 10 years or so. Well, that's not always true. There's new information coming out about ABio all the time, so ordinarily I would tell people, hey, just keep on it all the time. Don't do anything else with your life. But no, and in all seriousness, usually for the field, like what's considered to be out of date is around 10 years or so. And anything older than that is not necessarily irrelevant, just not necessarily cutting edge.
Yeah. Your mic is a little bit scratchy for some reason. I just invited the masses to this stream.
Come on in, masses.
If we're going to wrap up soon, or if anybody wanted to come in and comment on anything, Randolph Richards is here, and BrainBugs here, and Icarus is here.
The whole
Scott Duke is here. Oh, who's that guy?
Everybody's here.
Yeah,
all the kids from school.
Yeah, we only got 13 watching. Our papers generally draw 14 people. If we have a shitstorm with Danny, I can draw 35.
Yeah.
That says something.
Where are you, Danny? Sorry, can't do it today. Anyway, so we did a little bit better on this section. I think we should do even better yet on the next section and download some. Like downloading those papers it takes a while. You have to copy them and you have to Google them. And so, but I could try to get my shit together and we could do section. What are we on? Section 4?
Yeah, we will be on section 4.
We're on section 4, which is now beginning.
So this is integrating the chemical and the combinatorial and adaptive scenario in a geological setting. Randolph.
I feel like I've been summoned here.
You're still building stuff, I see. But wait a minute, I see trees.
Yep. This is Canada. We have lots of trees.
But isn't it cold out there? Like what part of Canada are you in? Well, no, you're in the one that actually is lower than Minnesota, like more southern.
Southwest British Columbia. I don't know offhand if that's lower than if that's.
No, that isn't.
Okay. So yeah, we're just I just have to that piece of wood at the end here. My finger's tilting it there but it's far away. It's I need to drill holes in the cement and anchor that into the ground. And so that's what I'll be working on today. That's the foundation for the framing that I need to build for the south wall.
So being in Canada, you have to drill through permafrost, right?
We've got the right tools for that.
Let us know
Oh,
if you
you're
find
on
Golden River
you're on the
there.
coast. You're on the Pacific coast, so you get warm weather, right?
Yeah, it's generally pretty moderate here, and our winters are kind of short. But that seems to be appealing to a lot of people who want to move up here from south of the border. So this is great. I seem to be interested in BC and one other place, I think Ontario somewhere. Quebec gets a lot of snow. Quebec is further east, so that's kind of interesting, I think. But
well, after the 2020 election, I unpacked my boxes. I was all packed up and ready to come up there.
Yeah.
But I unpacked now because I'm going to give the U.S. one more chance.
I'm hearing that quite a bit. Yeah. You're not the only one who's like there were a lot of people wanting to get set up. We had a lot of people questioning it before the election, the U.S. election, and so we just point them off to our government websites that talk about the immigration procedures. This is what else can we do? We're not an immigration company, but there's people who it sounds to me like they're very serious about moving up here, quite a lot, and now that it's a different political party that's mostly in power, I think they're like you. They're kind of deciding to kind of see how things go.
I seriously considered it. I was talking to my sons about it and seriously considered it, wondering if they needed computer programmers or if computer programmers had a chance of getting into Canada. But I understand you guys are building a giant wall on the border. That's what
no. You're thinking of Trump. Trump was talking about how there's a heroin epidemic, which is a big surprise to us here in Canada.
Right.
And, so he's going to build a wall here and make Canada pay for it. I'm not kidding about this. This came up as well. But
really?
Yeah, the big focus is on the Mexican wall, of course, but the wall between Mexico and U.S.
But that's what you're doing, Randall, is building the wall. You really
you're building the wall.
You just started building the wrong direction.
This is just going to be the studio, so it's a very small wall. It wouldn't be enough to keep people from crossing the border.
Well, I'm not very motivated, so it might keep me out.
Yeah.
I'm not worried about you guys coming over here. I'm really not.
Well, Minnesotans frequently cross the border for walleye because we don't have enough walleyes in Minnesota. They're fish. They're fish.
Oh, okay. I don't do fishing.
And just north of Minnesota in Canada, that's where the lakes really get serious and the walleye get better. So. Oh,
okay.
Yeah. So we frequently cross.
Do you think there's an overfishing problem, or is it just environmental setup of the lake?
I think it's environmental. I think it's the grass is always greener on the Canadian side of the border.
There's people here who think it's better in the U.S. They automatically think, oh, no taxes, can deduct mortgage payments and all this stuff. And but the healthcare situation and the public education and the gun control.
We have education?
Yeah. We have education? You mean there's places in the U.S. where... You mean there's places in the U.S. which don't publicly promote creationism? Holy shit.
I hope so. I hope there's lots of those.
Yeah.
Trust me, some of the schools that my friends know about are very pro-creationism. And it's like, whoa. Okay, then.
We do have private schools here too, and a lot of the private schools do get affiliated with some sort of religious institution.
Yeah.
So that way they can get additional tax exemptions. And so there's people here who are starting to petition the government to kind of more informally at this point, but to try to get the tax exempt status for religious institutions removed. So
smart idea.
Well,
did you watch any of our
come in would be huge, right? So.
Did you watch any of our paper reading?
I just tuned in, and I just saw the tail end of it. You were talking about Springer Link. That looks like an interesting website.
Yeah, it is. Yeah. Very good for searching papers. I like it, but Immutable doesn't even remember it, but he didn't like it when we did it, so
No, I remember now. It just took me a few minutes here.
took you a while. Okay.
I had to boot up the server memory. Okay, took a few minutes.
Okay.
What is the website address for that Springer link?
I put it in the chat, but I will do that again,
No problem.
and I'll put it in the description also, so that it's on this video in case you ever need it. So if you remember this video.
Somebody wanted one of our links. Wow.
Link.springer. I was trying springerlink.com. Okay.
Yeah. Okay.
I couldn't
that
find,
one is
I couldn't find this paper on that Springer link, though.
What's that?
Wow.
I couldn't find
This looks very
hot
interesting.
springs origin hypothesis, or the hot springs hypothesis on the origin of life. I couldn't find that on Springer. Maybe I need to search for just by Deamer's name. And remember, we have to call him Deamer now because we've been saying Deamer.
Okay, I'm gonna do a different.
I can imagine. I can imagine that would give problems for people who pronounce their name Deamer.
Yeah.
Oh, has his name been pronounced incorrectly all this time?
I guess so. We've been calling him Deamer, and we found out it's Deamer.
Yeah.
Oh, we call him that here in Canada too, Dalmer. We try to pronounce the L.
And we're talking about the scientist.
Yeah, there is no L.
Not the killer.
Oh, we're talking
that's
about. I thought you were talking about a psychopath. Okay.
Okay.
No, we're talking about the
well,
scientist.
that's the thing. The pronunciation has probably been changed to avoid confusion with.
It's not Jeffrey then. Okay.
Yeah, not Jeffrey.
Not Jeffrey.
We're trying to get this guy on the channel. Don't compare him.
Yeah, let's not do that.
I'm not comparing.
Okay.
Very different thing.
So I found some papers, but let's see here. I have not found that one. So anyway, but gotta learn how to use the search engine.
Well, they may have a limited search range anyway, as far as the publications they look for. Because this was in astrobiology, so I don't know.
A wild Leo appeared.
Hey, Leo.
Woo! Leo from the wild.
Oh,
Leo. He can't hear me.
Somebody wants John Maddox wants to debate me on evolution, and
Oh boy.
Why?
I'm not. I don't have sufficient expertise in evolution to debate it. So,
Well, you're in luck. You're in luck. He doesn't either.
well, the thing is, I think that would be a disservice to the audience if I'm going to defend evolution against John Maddox. He wants to debate me on evolution. I don't have sufficient knowledge on evolution to be able to defend it. So I'm saying no.
Still do it. I mean, you can easily still do it. All you'd have to do is just approach it from more of like a philosophical standpoint. All you'd really have to do, excuse me, all you'd really have to do is just ask him, do you have sources for this? And just keep citing the fact that like there's like rarely are you going to find a reputed professional in the field that agrees with any of the conclusions you're reaching. And given that I'm not a professional, I trust their word. So
better yet.
That's all you have to do.
Okay. When he brings something up,
what he really wants to debate is intelligent design, and I know that's a code word for evolution.
I want to debate that so bad with him. Naturalism.
Oh, really? I'll see if he'll do it.
Tell him I'm down. I will go on any platform other than standing for truths.
So I already tried to get BrainBug in as my debate partner on this, and John Maddox said no, it's got to be one-on-one. But maybe he'll change his mind with you. I don't know. I'll propose it again.
He'll
see what
say
happens.
no, but you should ask, and you should say I was talking to Leo Phileas, and he said he'd debate you one-on-one, naturalism versus intelligent design, any platform other than SFTs.
Good evening.
Pick a different web channel to do it on. Don't do it on his channel.
No.
Insist that he do it on a third.
Wait, who are we talking about?
This is modern day debates trying to arrange it. That's what's happening. So
Yeah, we're talking about Quantum John. That's what I call him now, Quantum John.
Quantum John. Okay, okay. Hold on. I just got here. Leo, that's an insult to quantum mechanics. It is. Okay, fuck off.
Tanya, I think you just phased out. Are your quantum strings working properly?
Uh-oh.
Guys, I'll be right back. We're hitting some turbulence. I gotta go check the quantum fluctuator to make sure everything's going right.
I know. Better make sure.
So how are you? So how are you lovely people accepting beautiful doing?
I think Leo was just waving goodbye.
Oh man, Rhinos just couldn't ask for more shit. Fuck.
Oh, fuck off, buddy.
Damn. All right. Well, I guess the bomb then we'll have to wait. All right. Fuck.
Leo, I was so excited.
Guys, hold on. Guys, we got a serious emergency. The quantum statistical capacitors are fluctuating heavily. Everybody back at the base, right?
Where did that stop, boys?
God damn it.
Leo, I gotta say, that is just really, really charming.
You put the word quantum in front of anything, and it just sounds big brain.
Yeah.
I just hope people caught the charm pun there.
No. I did. That was funny. But don't forget, quantum mechanics has a certain flavor to it.
Oh yes, it does. It's very umami.
Are you talking old factory or new factory? No.
Damn it.
You guys are fucking horrible.
Yeah, see, I came in with doing quantum jokes.
Sorry, my joke just stinks. That was really bad.
Leo, do you know how you did your eigenstate video last week that talked about the two values for the constant, the Hubble constant? PBSE FaceTime did the same exact topic on Friday,
Yeah.
I think it
You're
was.
copying me. What do you?
Yeah, they're copying you.
No,
That a professional,
PBS is looking to you for
professional
guidance.
outlet with an actual professional physicist has
Yeah.
to copy me.
I know. Fucking
What
shit.
you know, I tuned in.
Leo, okay.
They're pretty good. Matt
Leo,
O'Dowd
you
does a good job hosting.
Leo, you need to get yourself a little bit more credit because you're not a professional, you're not a scientist or whatever, but you understand quantum mechanics better than John Maddox and Standing for Truth and anyone else.
Look, Leo.
Hold on.
We can't call him
I
quantum
refuse-
standing for truth. We have to call him, is he standing or sitting for truth?
No. Okay, Leo, I still stand by what I said. I refuse to call him Quantum John, okay? Because that is an insult to quantum mechanics.
It's
Fuck
just
you.
so fucking funny. The
I know, but fuck you.
Quantum John.
Look, you know you're doing better in life than a person than like when I called him a Nazi, and now he actually does look kind of more hardcore like a Nazi.
Yeah, I mean,
I'm
you're
just-
a monster.
I'm just thinking, I'm like, John, I'm not like the best person on style, but that is not the best way to like. Appearance matters. I'm just gonna say that.
Does he have his very own belt buckle?
He might. I mean,
Yes,
he
it's a
apparently
quantum,
was
it's a quantum
housing with
super.
a roommate, and now he's having to move on. Remember, this is a person who had made $1 million and then lost it all almost immediately.
Okay, so, but nobody. I'm gonna point out the comment. Nobody actually go to the link because I'm gonna share it. It's from Icarus. It's pretty fucking funny. I'm gonna share.
Speed of sound that I almost were on the MDD once. Wait, didn't you go on MDD once, Speed?
Yeah, but do you know what happens?
When you tell people not to do something, you know they're going to do it.
Wait, hold on. The derivative of what is it? The derivative of hold on. Is it integration?
No.
Or is- no. It's
derivative
divided
with
by
respect to
date
time
time
of
with
this
ice
symbol
cream.
Wait, hold
equals ice
dot
cream
of
with
that
dot.
symbol.
one at a time. Jesus Christ, Leo,
So
go ahead.
This is saying the derivative of whatever. Let's just call this symbol Zilbot. It's not like actually a symbol that exists.
Yeah.
But we'll call it Zilbot to make this easy. This is saying that the derivative of Zilbot with respect to time is equal to the derivative of Zilbot with respect to time because that's what the dot means over the symbol. The
So
dot implies
I was only-
differentiation. So this,
So I was only slightly on course when I was reading that as date divided by date time and ice cream without a topping equals ice cream
Hold
without
on. You know what I always found interesting? I forget what this is called, but E of X, the derivative of E of X is always E of X.
Oh, the exponential function.
Yeah.
Icarus is asking. It's not a symbol. It's not a commonly used symbol, I guess.
well, no, the symbol without the dot is not like actually a symbol. I've never seen that. With the
Well,
dot,
not
it's an
one
I. Without the dot, it's just
Not
nothing.
the one that's typically
Quantum
used.
mechanics, calculus. I don't
So
know.
was that I as an imaginary number?
No. Okay.
No.
Let me share this.
Yeah.
Hold on.
No.
Let me share this. Let me share this again. Let me
no,
share
no,
this.
Because it looks like
Move
I
on,
agree
move
with that.
on.
The
It's
topic
not
Nope,
is
we're not going to move on.
Leo,
We're gonna go through this.
show them the derivative notation with a dot somewhere. There must be an example of it.
Yeah, physicists
or
talk
you
about
know, or
indicating
I'm
you
gonna
know,
do this in two separate ways. So
It's an
you
iota.
see the symbol here. You'll notice it's the same as here. It's an I without the dot. Yeah, an iota.
iota.
yeah, no, because it does look like an
This
eye.
symbol,
Cryptocurrency.
God damn it,
this
women!
symbol
I mean,
d over dt means the derivative with respect to time, and it's saying that you're taking the derivative of this value, this variable, with respect to time. The dot, like if you take just the dot, that's derivative. That means derivative. Oftentimes you'll see that in like vector calculus and stuff like that. So what it's
Just the
saying is
dot.
derivative of this symbol is the same as a dot above that symbol. This symbol here is just a lowercase I. So they're making the I doesn't mean anything. They're just making a joke on the lowercase I, saying that the dot
Yeah.
represents
Okay,
the derivative.
It
of
just
that.
occurred to me, and this is not a novel observation, but does the eye represent an intelligent designer?
Maybe. Actually, why did I stop sharing my screen? Because that article I wanted to share with you
well,
guys.
Leo, I wanted to ask you. I wanted
That's the
to.
case. The first one
you
was
should-
beheaded, I guess.
You should. Let me try again. You should talk about first principles in regards to derivatives, if you know what I mean.
Jesus
Okay.
fucking Christ. If I have to go through epsilon delta definition of the limit one more
Let
fucking
me
time.
clear this up, please.
Yes.
Okay. I don't know if you can see this, but let's see. Down here we
Yes.
have
How to do it.
okay, different kinds of notation for derivatives, basically. Let's see. What the hell? So right down here, you see occasionally they use a dot instead of the
X dot,
instead
X
of the
dot.
d over dt, whatever. They use a dot, or they use 2 dots for the second derivative and 3 dots for the third derivative, right?
You know what I always found
That was a
easier for
bad
me
joke.
is f. I always found that f prime of x. You know what I mean? Because sometimes they have like d of y over d of x equals d of x. Like I don't know. I don't know. I
Hey.
find certain notations better than the others.
Okay, hang on a second. Hang on a second. I had something to say. Moderation. Sorry.
Oh god damn it! Really, Speed?
Sorry.
We were having a nice chat about quantum mechanics, and you're gonna bring Danny in.
I don't know anything about quantum mechanics, so you're
I
safe.
apologize.
Hello,
Well,
Danny.
at least you realize that. Good morning or afternoon,
Hello.
whatever.
Hello, Danny.
How are y'all?
A little bit more depressed.
Okay, should we be doing this on the tail end of one of our paper documentation? Should I
I
split
don't
this
think
into
so,
two?
but
I
you
should-
decided to do it.
Do it. Everybody needs to learn more about math. Every fucking buddy needs to learn more about
No,
math.
but I'm
No,
not
you
talking
don't.
about the
I
math.
generally agree with that
I'm
sentiment.
not talking about the math. So I think I might take this down and split it in two.
Math is science. Or
Yeah.
math,
You wanna
whatever.
give
Math
us a
is
new
important.
StreamYard link? Is that what you're saying?
What's that?
You want to give us a new StreamYard link? Is that what you're saying?
We could do that. But no, let's go on with this one. I'll just take it down and split it.
Well, I mean, if you take it down, the chat's gonna be gone.
No, it's not.
Oh, that's right.
Oh wait, no, it won't.
Well, I saved the
You
chat.
can
You
do
can do. You can put a part 2 in the description with the timestamp, and then people can skip ahead to it.
Oh, okay.
I
Well,
think you can-
or skip it.
I think you can trim the video once it's over and then upload the second half into make the second part its own thing.
Yeah, but it will get rid of the chat. But anyway.
Yeah, chat's valuable. Don't want to lose the chat.
Yeah,
I'm just.
by the way, I'm just going to state outright. I find the notation that physicists use retarded for derivative.
What, the dot?
The dot? You mean the dot? You don't like it?
No,
I
I'm
like
no,
Well,
Prime
it
notation.
abbreviates.
a lot better.
It abbreviates things.
Yeah,
Which
it
is-
makes the equations look a lot simpler.
Yeah, but primes are just as simple.
Yeah, I mean, look at that. That is a lot simpler.
The prime is just as simple.
Yeah, but the prime just is stupid. Why use prime? Why not use a dot? A dot is just cooler.
Because the prime came first.
You can
Well,
please
fuck
some of the people some of the time. What is that? I don't know. Anyway,
You won't see a differential equation in the textbook use dots instead of.
moving on.
Not until I fucking write one.
Wow, good luck. Have fun.
I'll do it
Have
just to
fun
piss
getting
everybody
loaded.
off. Just to piss them all off, little bastards.
Yeah. Oh God.
Yep. How you doing, Danny?
Oh, I've been just busy.
Hi,
How's your-
How's
Danny.
you doing that exam?
How's
I'm working on it now,
Still?
Oh,
so nothing new.
So what are you doing here?
Oh, I'm just, giving everyone heart palpitations,
Yeah.
I mean, at least you realize you do that.
Yeah, you scared the shit out of my panel here.
What are you talking about?
Well,
yeah, I'm sending an email to my therapist right now.
It's good to take a break too, right?
Feeling that I get when Danny enters the room. But Speed, I did want to share an article, and I'm betting that some of you guys have probably seen this, but
I've seen it on your timeline.
I think it'll be
I even
pretty.
commented on it.
Yes, you did. Let me know when it's up.
It is.
Ooh.
This is a pretty interesting article. I'm gonna let you guys read a couple snippets from it.
All right. Okay, well, go back up.
I'm gonna hold on. I'm gonna highlight them, and you guys should read.
Did you
Well,
give
no,
us a
hold on.
link?
Shouldn't you go up all the way? Are we reading the entire thing, or just
No.
snippets?
No, we're not gonna read the entire thing.
All right.
Leo, could you give us a link, please?
Yes. When
Can I read, please? That's what I'm doing.
Can you read? I don't know.
Yeah, that's
Are
what.
Can you read? Do you know how? Can you read?
Can you?
Can you do it?
Okay. May I read? Is that better English for you?
May you? I don't know. May
Do
you?
you?
Jesus Christ! I'm gonna fucking read.
Miracle
In a
or
recent study, fuck you. In a recent study published January 29th in the Journal of Physical Chemistry, Chemical Physics, that seems redundant. Researchers explored another explanation showing that a quantum phenomenon called proton tunneling can cause point mutations by allowing positively charged protons in DNA to leap from place to place. This in turn can subtly change the hydrogen bridges that bind the two sides of DNA's double helix, which can lead to errors when it's done for DNA to make copies of itself. I like to point out that there was one time where I mentioned to Immutable that quantum mechanics plays a part in DNA, and he called me standing for truth. I shit you not.
Quantum
know,
mechanics is part of it's
you know what I
chemistry.
like to call chemistry? Applied quantum mechanics, because that's kind of what it is.
That's exactly what it is.
Yeah.
It's
Okay.
applied
Chemistry
quantum mechanics
is
to, like, pretty
quantum
much just
mechanics.
electrons.
All right.
But I mean,
all right. I guess.
Here's the really interesting thing for me about that, right? Is it's not too hard for a charge to be delocalized around a molecule, but for it to transfer between different molecules is kind of unusual, because I don't know what would kind of propagate it to move from one molecule to another.
Prompt.
Unless there's some
Prompt.
kind of
Yeah, prompt.
well,
All right. I guess I'm reading again. However, due to the calculations used, the authors could model only small portions of a DNA strand at the level of single bases and base pairs. That means the model doesn't include the two sides of the DNA double helix, nor the pairs located elsewhere in the strand. Hay noted, these nearby structures may have a, quote, significant effect, unquote, on how proton tunneling unfolds, but to model the entire DNA strand would have required an enormous amount of computational power, he said.
Yeah, the article just talks about how proton tunneling, honestly, is probably one of potentially one of the larger reasons for. I'll just scroll to a random place and let you guys read if anybody wants to. They don't have to read out loud, but in head. But
Well,
just how
I'm going to anyway.
It's likely a more. It contributes more to point mutations happening than not.
Well, Leo, can I read anyway out loud?
no.
Yeah, well, Leo's getting me that link, but
Well, I'm gonna have to stop sharing to do that.
okay.
I mean, the thing
All right.
is, I'd be curious.
Then
to
put
read-
it back. Then put it back afterwards because I want to read. I don't get a chance to read out loud that much.
Immutable is trying to say something.
There's probably a good
My
reason
bad.
for that one, but also,
Fuck you.
I you would need a certain amount of energy to cause tunneling to occur, wouldn't you? And the hydrogen bonding between base pairs seems like that would be a fairly
Tunneling
not
is
rare
random.
enough.
Its
Abnormal.
probability increases as you add energy to the system.
Yeah, but I mean the system's already
Particles
fairly
tunnel
stable.
randomly, even without added energy in that system. And it,
Yeah, the
with
thing
protons,
is,
it actually, the
immutable.
thing with protons is it happens way more frequently than we think it does.
Well,
if
usually,
if things combine to create a certain set of states, right, and there is a pathway in those states, then there's something's going to happen, and that's how quantum affects biology, and it happens in almost every molecular reaction. I mean, you have a state diagram, and you have quantum states, and that is a complex system. And if there is a path, then something will happen. So when they tell you that there's quantum effects in biology, that means that somehow those states combined so that there was a low energy pathway for something to happen that you wouldn't ordinarily think would happen, right?
Yeah.
Well, I mean, yes, but no, because quantum tunneling is statistical. It's like vacuum field fluctuation. It just happens.
It's
like
statistical.
it doesn't have to have something to cause it. It could be a state, because if you add energy to a system, you can increase the probability with which it happens, but it happens regardless. I mean, it's one of those things where it just happens.
Does. I mean, but typically, if I recall right, I mean, I'd suspect it happens more in like gaseous phase.
Technically, yes, because you're generally, at least in most instances, you're at a higher energy state. So, given that there's more energy, there's a higher probability of tunneling through that Coulomb force, because naturally, and I know you know this, that's the force that protons have to overcome. That's the barrier, so to speak, that they're tunneling through. So, the more energy there is, you increase the probability. But I guess what I'm saying is that there's always a base probability that it can happen. As you add energy, that probability climbs up.
Yeah, I'm not denying that. I'm thinking of it more about on a structural level. It's kind of like if you were to like swing a hammer at a very at a particular point, like in a well-organized lattice, or kind of tug on it a little bit. One of the reasons it usually doesn't come apart is because of the fact that even if it's enough energy to kind of sway the lattice one way or another, it usually isn't enough to cause the entire lattice to dissolve or to perturb the lattice structure that greatly. And DNA can kind of be thought of as a disordered or a non-traditional.
You have a bit of static, by the way.
Okay.
Am I the one who noticed?
I mean, it's real small, but yeah, I don't. Wait, Speed's not muted, is he? No, he's not.
No. All right, yeah, Leo, I put the link in the side chat for you.
Awesome, thank you. Did you throw it in the YouTube chat?
No, let me do that.
Yeah, there's all sorts of weird fuck shit that happens in chemistry.
You mean quantum mechanics?
Well, I mean, chemistry is fundamentally quantum mechanics.
Well, yeah, but the two are whatever, distinction without a difference.
Well, not really. I mean, because when you think about, like, for instance, a helium atom or something like that, that's a 2-electron system. And that's a system far, far, far more complex than a single 1-atom system or 1-electron system like hydrogen. But you can still formulate the idea of an atom based upon that principle.
Oh wait, hold on. Quantum mechanics tries to explain, tries to explain how atoms are formed, and chemistry tries to explain how they interact.
Well, yes, but chemistry would end up referring back to quantum field theoretical descriptions, like quantum electrodynamics and strong interactions, which are the two that are.
Well, yeah, but
like most atomic behavior. Weak interactions would really only come into play with things like radioactive decay and nuclear fusion. But other than that, it's mainly just electrodynamics and chromodynamics.
Yeah, pretty much.
Guys, I'll be back in just a minute. I have to go get some quantum water out of my garage.
All right. Be sure to quantize some of it our way.
Wait, before you go, Scott, I do have one important question to ask you. Unless you
go right ahead.
Okay,
go right ahead.
Is the quantum water a liquid or a solid? I guess you'll tell me when you get back, right?
Or that's right. I don't know. It's indeterminate right now.
Or is it in a superposition?
I'm loving all these jokes. Danny is over here lost as hell, though, but whatever.
There were two quick paragraphs I wanted to read here for you guys that I think are in a lot of ways the crux of the article, so I'm just going to jump right in here. Whereas for GC, it has this rather large reverse barrier, which means that the state is somewhat stable for a significant portion of time, Slocum said. So once a proton hopped the energy barrier of a GC pair from one side to the other, obviously, it may stay in its unstable position for some time. If this occurs just before DNA replication begins, the proton may get stuck on the wrong side of the strand, Slocum said. That's because to copy itself, DNA first unzips, breaking the bonds between the base pairs. An enzyme called polymerase, RNA polymerase, I believe, to be specific, then swoops in and starts fitting new bases into the open slots, like puzzle pieces. The problem is that when polymerase encounters a proton in an unstable position, it can end up selecting the wrong puzzle piece for the attached base. For example, a proton may leap to a G, and when polymerase comes by, the enzyme attaches a T rather than a C and doesn't catch the error. And obviously, that would be the mechanism that causes the point mutation. Obviously, and the one paragraph that that Midnight read that was up here a little bit, where it's not there's we have to do a lot more with this, but it seems at face value that what this means is that tunneling could have at least a more prominent effect than would otherwise be considered in genetic mutations. And I think that's pretty damn cool, though. Actually,
yeah, a fascinating article that Immutable laughed at me for.
No, I don't think Immutable laughed at. I think he just had some questions.
Well, no.
Reasonable questions at that.
No, I'm still referring to what he said a few months ago. Never mind. It was a rub at him.
Boy,
you see,
long memory.
You see quantum physics like pop up in areas where it really doesn't belong, and it's like, oh, for fuck's sake, come on, guys, really?
Yeah, I agree with you, but I agree with you, but you should have known that we're talking about physics. I'm sorry, biology, right? It's made from elements. Obviously, quantum mechanics will play a role in it. Quantum mechanics plays a role in literally everything.
In a sense, yes.
Except, like, when people are describing it, they're not usually thinking, like, aha, how am I going to describe this quantum mechanically using a Schrödinger equation with, like...
because people are more focused on the bigger picture. What the fuck is this?
Why be right when you can approximate?
Who's, let's see.
It's Lil BB.
Uh-oh.
Lil BB.
Live, calling out some clowns, Chris. Wow, I guess he was butthurt about.
Did anybody see my conversation with him last night and Joel?
Who did?
Oh, what happened?
Oh well, LVP cursed at me, but I think he said we're cool. I think I really irritated him. He said I was playing games, and then
what video down, Danny?
They did, and Joel, of course, started talking about things that he didn't know he was talking about, but
that's the theme of creationists.
Creationist and atheist.
I'm proud of you, Danny. I'm proud of you. You irritated John.
Well, it depends on the atheist.
But the thing is that I had no intention of irritating John, but I think the problem was that now there's no recording, so this is my recollection. My recollection was this: he asked me. I made a criticism of Andrew. Andrew told LPP that it's impossible that an iron ore could be extracted from rock by itself, right? To say non-intentionally, and I piped up and I said you shouldn't concede that, because if you actually think that, then you should be an ID theorist, right? And I said that.
Wait, hold on. Which Andrew? A rational empiricist Andrew?
Right,
Andrew
that one, right? He conceded that it was impossible. And I said, look, I don't see that, like, and I gave a better example. I don't see the impossibility of an iPhone being assembled unintentionally. I don't see a contradiction. Right.
Exactly.
And
there is no either logical, quite frankly, there's no physical contradiction.
Right,
with that
exactly.
either.
Yeah. It's now we could say it's highly improbable or whatever, right? That's another different question.
Yeah.
But I was trying to tell Andrew, like, you don't want to concede that, because if you concede that, you should be an ID theorist, right? I think that, or at least there might be a reason to be an ID theorist.
I mean, yeah, you have a point there. Yeah.
Yeah, and but then of course LPP,
Quantum John.
No,
of course he was like, wait, he did this little wait, like you think that an iPhone could be a symbol all by itself. So we discussed it, and I said, look, I'm just saying it's possible. And then what I thought he did is he changed the question to plausible or probable. And I said, well, it's perfect. So we had a debate about logical, plausible, and probable. And I told him essentially I disagreed with how he was using the terms. And then he called it a semantic game, and he got really irritated. And then I sort of backed off.
He does that. I'm going to be honest. With Quantum John, one of the first things he's going to do is, just give me a second here. One of the first things he's going to do when he doesn't know how to respond to what you said is claim that you're playing at semantic games. Because the point that you brought up, Danny, of where maybe I'm overcomplicating it, but it seemed to me that you were saying that you were expressing something along the lines of a distinction between impossibility and logical impossibility, and perhaps even metaphysical impossibility.
We talked about that. I mentioned that to him.
A little bit harder.
I mentioned that to him, and I said the exact same thing as you did. I said I don't see a contradiction or a tension with the laws of nature and an iPhone being assembled. But I honestly, the rest of it was a blur. I'm not going to speak. I mean, he said we're cool, and
I'm going to be honest. I'm going to be honest, John. I've always said this. I don't think John is a stupid person. In fact, out of the group, I got to be honest, I think he's one of the more intellectually inclined individuals. He just comes off so boastful and pretentious that it's hard to have a discussion with him. He's very, very much, what's the word I'm looking for? Confrontational when he's discussing with people he knows.
God, I so disagree with you, Leo.
That's beside the point.
He's an idiot savant, Leo.
That's beside the point. The point is that I think that initially when you made the distinction between logical and physical impossibility, that it didn't quite click with him. But I'm sure if he had time to think about it, he'd get it.
I think he accepted it. No, he accepted it. He accepted it. Okay. Yeah. And then he changed it. He changed or maybe I changed it. I wish we had the video. I said I think it's physically impossible that I can jump over the moon. Right? I think that's physically.
That is physically impossible.
But I don't think it's physically impossible that an iPhone would be like assembled naturalistically. I don't see the physical impossibility. And then I honestly don't have good memory after that. I don't know.
Can I say something really quickly?
Yeah.
I would argue that one could make an argument that maybe I'm just equivocating on the word, but I think everybody will understand what I mean when I say it. That I would argue that an iPhone was developed naturalistically. It was natural mechanisms, although utilized by through the intention of some intelligent agent, they were still natural processes, natural materials utilized. Everything about its construction and development was natural, in my opinion. So I would argue that anything that's ever been developed, even if by humans, is developed naturally.
Yeah, I understand what you're saying. I would just change
materials. But I know you, Danny, you think that there's a non-natural aspect to human.
We don't even have to talk about that, right?
Yeah, but you think that human intention is contained in something non-natural. So I understand that somebody like you would object to that.
Well, no, we don't even have to. You don't have to be a non-naturalist to say what I'm saying. You can just say there are non-intentional explanations and there are intentional explanations, right? A naturalist accepts that.
I would agree with that. And actually, just the other day, Speed had was quoting something from
distinction. I just want to cover first.
Go ahead.
I just like to say, I think like when they're talking about this stuff coming natural, they're talking about it directly occurring in nature, not indirectly by nature creating nature.
Yeah, exactly.
So we should bring in the terms directly natural and indirectly natural.
That's why I said at the beginning that one might consider what I'm saying, equivocation of the word naturally in that case. But
this is why
I argue that naturalistic mechanism.
Well, but probably we could say implicitly natural and explicitly natural.
Well, you're right, but you're right. But people generally use the word artificial to distinguish the two.
In a sense, yes. Sometimes natural means like when you get you buy, say, a jar of honey and it has all natural on it. That doesn't mean that the only mechanisms that had a play in this were natural. It means that artificial or synthetic chemicals were not added later by humans at any point. It was developed from the bees out of the hive into the jar. So, I mean, I get the distinction, and that's why I preface what I said with some might consider, you know, my take on this equivocation on the word natural. But I did want to touch on, Danny mentioned it, the difference between intentional and non-intentional explanations, because Speed, I believe it was on this channel, Speed, correct me if I'm wrong, the other day, we were sharing a video that Praise had where we had up something that William Lane Craig was talking about, and he made this distinction. And this is why I still actually have quite a bit of respect for Dr. Craig as a philosopher. Other people may disagree. That's their imperative. We're not going to talk about it anyway. Where he made that distinction where he said, you know, if I notice that the pot of water is on the stove and the stove is on, I could ask my wife, why is water boiling? And she could say, well, it's because the heat is being conducted by the plate at the bottom of the water pot, and it's transferring its energy to the water, and the molecules in their excitation due to increased energy are escaping in the form of steam. Or, which would be a non-intentional explanation of why water is boiling. Or she could say, oh, well, I'm making a cup of tea. Would you like some?
Can I share a 7-minute video? I think y'all would really enjoy it. I think that this is one of the best videos I've ever.
I'm down, but it's not my channel.
It's not copyrighted.
One thing though, I would love to see your video, but one thing, wouldn't it be so cool if like a polar bear came in and jumped on Randall right now?
Randolph would have to fight it. So, this is a really good
video.
Randolph would have to fight it. You know, I got my money on Randolph. I think he could take it.
Okay,
well,
you ready?
It's not going to happen because they're quite a few bridges and waterways away. They have some time yet to prepare.
Okay.
Wouldn't it be great if a polar bear in a scuba mask attacked him?
Leo, this reminded me of what you were saying. I watched it yesterday, and I've seen it years ago, but I rewatched it, and I just love this video.
I've seen this a couple times. Richard Feynman is fucking brilliant.
And you push them, you can feel this pushing between them. Turn it around the other way, and they slam together. Now, what is it, the feeling between those two magnets?
What do you mean, what's the feeling between the two magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these two magnets together.
Listen to my question. What is the meaning when you say that there's a feeling? Of course you feel it. Now, what do you want to know?
What I want to know is what's going on between these two bits of metal.
Magnets repel each other.
And well, then what does that mean, or why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course, it's an excellent question. Okay.
Can you pause this just really, really quickly, please? Notice there, the whole time, Dr. Feynman knew exactly what the guy was asking. He was trying to get the guy to get at the reason why he was asking the question. I just want that to be obvious.
Well, I think it's less of that. I think it's more so that, look, when you're talking about questions of why, right? I think most people are talking about questions of how. But like, go on to explain, there's hierarchical levels of explanation that you can go into in terms of why two magnets repel each other, and that can go from, you know, a basic physics explanation to quantum field theory. QED.
He talks about that,
Hang on. What I was getting at is the sense. What is the sense in which you're asking the question? What's going on? What's happening?
Well, yeah, but
there's multiple definitions or explanations that give what do you mean when you say what is going on here?
I wanted to say something before.
Go ahead. One more thing.
Yeah, I just wanted to say that the how sometimes explains the why.
Okay, now let's listen to Danny's.
Does anybody agree?
Yes.
Yeah.
Sort of.
I don't know.
Danny. Roll.
The problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens? For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. That satisfies people. It satisfies, but it wouldn't satisfy someone who came from another planet, knew nothing about things. You first should understand why, when you break your hip, do you go to the hospital? how do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. All that is understood by people. And when you explain a why, you have to be in some framework that you allow something to be true. Otherwise, you're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. Not always. Some husbands aren't interested in their wife's welfare when they're drunk and they're angry. And so you begin to get a very interesting understanding of the world and all its complications. In order to if you try to follow anything up, you go deeper and deeper in various directions. If, for example, you could go, oh, why did she slip on the ice? Well, ice is slippery. Everybody knows that, no problem. But you ask, why is ice slippery? That's kind of curious. Ice is extremely slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me. Ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get. Greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery, because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. It's capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult a why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after all. That's my idea, that the deeper a thing is, the more interesting it is. And we could even go further and say, why did she fall down when she slipped? That has to do with gravity. It involves in all the planets and everything else. Never mind. It goes on and on. Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person that doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. And you say, but that's very strange, because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact, the electrical force, not magnetic exactly in that case, but it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in microscopic details. There's other forces involved, but this is connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start, that we can start with, to explain many other things that looked like they were, everybody would just accept them. You know, you can't put your hand through the chair. That's taken for granted. But that you can't put your hand through the chair, when looked at more closely, why? It involves these same repulsive forces that appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than in ordinarily. And there it has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force until it's large enough at a distance that you can feel it. But it's a force which is present all the time and very common, and is in a basic force of almost, I mean, I can go a little further back if I were more technical, but in the early level, I just have to tell you, that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion, or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. For example, if we say the magnets attract like as if they were connected by rubber bands, I would be cheating you, because they're not connected by rubber bands. I shouldn't be in trouble. you'd soon ask me about the nature of the band. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have cheated very badly, you see.
I love this
I'm
man.
not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. And to tell you that that's one of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others. And those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately. That our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good any job of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
Wow.
My jaw.
Like about that is that
Danny, can you link that for us, please?
Yes.
Yeah. Do you like? Have you seen that video, Speed?
Yeah,
No,
I've seen it.
I did it before, but I loved every minute of it. My jaw. I want to
point out is that Richard Feynman definitely has autism. I could pick it up in the way that he kept moving as he talked. He was excited to be talking about what he's talking about. Anyway,
I mean, I don't really care, but that's good to know.
The greater point that he was getting at, where it's hard for me to explain what something is because I can't reduce it to something more simple that you already understand. I can't tell you how many times I've run into that problem with explaining something in physics. Oftentimes, I've been asked, well, why do magnets attract? You know, I have questions about electricity and magnetism, and it's hard to explain them in terms of something simpler for the very reason that Dr. Feynman laid out.
Well, yeah, and for me, I just, oh God, that video, it just, it feels beautiful to watch. You know what I mean? Like it's just you watch that when you watch that you get a sense of the beauty of the universe the way he explained it, right? I don't know. Maybe it's just me.
Yeah, it is cool.
He seems like a lot of geniuses. You hear about these genius idiots who are just no good to anybody but one particular field where they just seem to master it. But he seems well grounded. You know what I mean?
Oh, yes, that was Feynman. That was
being done. Yeah, let me try again. Having autism is a spectrum after all. Like there are some people who are extremely, extremely high functioning, and then there's Potato.
Did anybody ever see some of his? Apparently, he had some audio or video lectures of some of his classes recorded.
The Feynman lectures, yeah.
Getting them on Audible or something like that, and walking. When I was losing weight years ago. Very good.
Feynman lectures are on audio?
Yeah, he has a collection of videos on Audible or something like that. I don't know. I think I paying them to Audible.
Yeah, the Feynman lectures on physics, the 3 books, are based off of 3 lectures he gave at, I believe it was Caltech in the 70s or 80s.
Yeah, it's great stuff. Yeah,
the notes. Yeah, the books are the notes from those 3 lectures that he gave.
Yeah.
That's why there's 3.
Yeah,
he gave one on classical mechanics and thermodynamics. He gave one on quantum mechanics, and then he gave one on electromagnetism. He gave one on classical mechanics, thermodynamics, a little bit of special relativity. The next one was electromagnetism and special relativity, and the third one was quantum mechanics.
Nice. Now, okay, you guys know that Landon Knoll actually met him, right?
Landon Kirtnell studied under Feynman.
Well, yeah, that too, but lucky guy.
Yeah, he also knows Leonard Susskind as well.
Oh, wow.
Oh my God, that's shocking news.
Too. I mean, he's one of the propagators of string field. Well, string theory, not string field theory.
I would argue one of the co-founders of it. He wasn't like a Michio Kaku or anything like that, who is more of a science popularizer than anything else, in my opinion.
He does research with string field theory.
Yeah, mainly focusing on like ADS CFT correspondence, which was developed by Juan Maloseda, I think in 1996, something like that, and then the holographic principle, which are the biggest areas of at least fundamentally string field theoretical descriptions that we have, but they're not really string theory in the sense that we consider it in terms of the mathematical theory that most people are familiar with.
Well, I mean that's a level of mathematics that's so fucking intense.
But I was very happy watching that. Thank you, Danny. You've redeemed yourself a little bit.
I think he's also raising a pretty big philosophical issue that, not issue, but like question. But I am not prepared to comment on it. I think
would you at least mention what you think the question or the issue is? Just because I'm curious to know what you're taking.
I think you did a really good job of how things are connected to what we already know, to our knowledge base. And I think that was the important thing. And I hope that's what you're talking about, Danny.
No, it's a rather benign point that I'm thinking about. But the point is that there's going to be an ultimatum, right? There's going to be a no further why, right? So there's going to be a point in which there's right. I just don't. I have to think about whether that's in principle discoverable, and I just have to think about it. I don't really have any strong views, but like I just don't see why you could, if you take something to be. Sorry, the dog's going crazy. If you can hear him bark, I think there's like an epistemic issue with getting to that fundamental thing that's no longer explained. I just think you could always ask why.
Yeah. I mean, I would agree to an extent, but I think
it's a matter of choosing.
Go ahead.
If you're going where I think you're going, I think it's a matter of what axioms you choose to endorse.
Yeah, and so that kind of we've had previous discussions about the instrumentalism and scientific anti-realism, but I think this is a little bit of what the anti-realist wants to talk about, like this notion of like why seems to be like a practical thing. Although maybe I don't know. I have to think about it. I don't really have strong views. My philosophy of science in this area needs to be really brushed up before I can speak any more about it.
Yeah, I mean, let's tackle it at a different date then. In that case, going back to what Leo said, I think the main reason, and I think it's Sean Carroll on one of his recent AMA videos that he explained this, but that ADS-CFT is really sought after because it serves as a toy model for understanding quantum gravity and.
Well, yeah, that's the whole of string theory. What we found is that things like ADS-CFT correspondence have dominated in that because they have the best descriptions for the potential mechanisms through which we could unify quantum mechanics with general relativity. Like string theory has never actually been considered as a legitimate, viable model that actually applies to our physical reality by the vast majority of physicists, simply because it was originally developed to explain something it never even came close to explaining, which was quantum chromodynamics. Gauge field theory went out there, and then it was just continuously modified in a variety of different ways. You've got M theory, gauge gravity dualities like ADS-CFT correspondence, holographic models, all these things.
I mean, have you ever read?
Some of them showed more promise than others.
Have you ever read?
Been a sort of a toy model for physicists to play with as a means of trying to understand more about our reality.
Well, have you ever read The Elegant Universe?
No, but I believe isn't that by Brian Greene?
Yes. Like in it, if I remember correctly, in it he explained, he explains how quantum mechanics and general relativity, basically what he was trying to say is that from his calculations and everything he's done, the four fundamental forces seem to spring forth from the current model of string theory he had at the time. Now this is an old book, obviously, you know what I mean? But
that's what string theory was. It was a way of unifying. It wasn't string theory was never just a unified field theory. It was a theory of everything. The problem is there's 10 to the 500th viable solutions to it. We've only ever just assumed that our universe would fall into one, though given right now, all the observations that could be made with our technology have not been made, and we do not have the technology to make further observations that could potentially
it's unfalsifiable,
so to speak, the string theory. But string theory There isn't any like one model for quantum gravity that most physicists hold to, because all of them have major problems, especially observational problems. Right now, all of them are fundamentally unfalsifiable.
Well, yeah, but
I think string theory can be developed and refined to a further point where that 10 to the 500 number drops significantly.
I mean, I just see
tried, like, I think M theory is an attempt at that, but it didn't drop by any significant amount.
Look, I just see the 10 to the 500th power just being each its own universe.
Well, see, that's how a lot of people have traditionally viewed it, that there's just multiple different universes, but that's actually not implicit in the math. The math just says that there's 10 to the 500th viable solutions to these equations, and we've only ever really assumed that our universe would fall into one of those solutions.
I mean,
thus far, we haven't observed that it has.
I'd imagine a large majority produce degenerate universes in terms of like the end result.
Wait, what?
I'd imagine a lot of those statistical variations end up producing something similar to our own, or produce the same type of thing.
I mean, within string theory, yeah. I mean, if you took it as that there are actually 10 to the 500th literal universes, most of them would probably look very similar. That leads into one of the objections that I have with fine-tuning arguments, but that's an entirely different road that we don't actually have to go down right now. So,
no, yeah, I mean, you do see the fine-tuning argument as just a design argument. That's how I see it. Right?
Well, yeah, that's what it is. The point that I'm getting at is that a lot of the claims that, like, it is my view that the universe isn't actually fine-tuned, and that there isn't anything that in any definitive manner, let alone a potentially definitive manner, points to the universe being fine-tuned. So I don't.
I mean, but hold on.
I don't know.
Hold on. I have a quick question. But just because you say the universe is fine-tuned, does that immediately imply a creator?
Well,
like, why couldn't nature, why couldn't nature make a universe that's, that has the values that it does for life to exist?
See, that's the thing, is that number one, I would argue that yes, a fine-tuned universe implies an intelligent designer, because that is implicit in the term fine-tuned, and that's why I would argue that in a lot of ways it's really a circular argument. It's describing the universe in such a way that it would require an intelligent designer, and then inferring from that thereby it has an intelligent designer.
I mean, for me,
the second point that I wanted to touch on was the idea that all the values for all the constants and quantities and parameters that govern reality are arbitrary. And this is what I mean when I say that. They're arbitrary in the sense that they are based on arbitrary systems of measurement that humans develop, like the meter, the kilometer, and we could go up to,
this is just labels
on that, and we could go down to picometers, but they're all based on the meter. Hold on. They're all based on the meter, which is an arbitrary decision that humans made for measuring things. Same with pounds. And to every form of measurement that we have, from electron volts to joules to Kelvin to meters, all of that we utilize in physics are all arbitrarily decided upon.
Okay,
when we talk about the universe having values, it actually fundamentally has no values at all. We prescribe values to it as a means of quantitatively describing.
Yes, they're descriptive, not prescriptive. My question is, haven't they ran simulations where they tweaked these values and the universe came out different?
Well, yeah, we changed the values based on how we measure them, and naturally, the problem with these values is the reason that they're really precise. Any one of those values could be measured out to infinity in terms of its precision. That's because of the quantitative system that we use to measure it. There isn't actually a value there. There's something that's consistent and uniform, oftentimes symmetric, and we can quantify that. That's why things like pi, define structure content, or constant, many of these other constants, Planck's constant, can be measured out to infinity in a theoretical sense, because there isn't actually an objective value there. There's just reality, and we quantify it as a means of understanding, describing, and communicating it. So we can change the things in the universe that appear to be consistent which is fundamentally going to change how the universe operates. But that doesn't really mean anything in terms of the universe being fine-tuned.
So, and you know,
Yeah, right. Well, whatever.
I remember Richard Carrier talking about this one time. He's saying that if the gravitational constant actually was changed a little bit, things would still adapt, and we'd probably still have a lot of the same stuff we have now.
Yeah, that's one of the constants that could be changed. There's several constants that could be changed that wouldn't have.
In theory, we haven't actually proven that they can be.
Obviously, as far as we know from simulations that we can run, wouldn't have much of a significant effect on the structure of the universe. But the thing that needs to be remembered is what we call the values that define the constants, quantities, parameters, what have you, that govern reality. We can ascribe any value since we invented what a value is. They're not something that's objective to reality, in my opinion.
You have to label it somehow.
But
this is just the language
exactly. That's exactly what they are. They're ways of quantifying something in such a way that it allows us to put a label on it and understand what it is.
If the Marklar on planet Marklar use a different measuring system, we'd be able to find out a way to convert that to our numbers, and we'd still be able to agree on things.
Exactly. Because it would still fundamentally be communicative. But the point is that
fundamentally that value is still whatever that value is. We
it's just described. It's described in under different arbitrary conventions. But the thing is that regardless of the arbitrary conventions that are ascribed to what I'm going to call a value, you could change what the value objectively is. But it's no matter what you set that value to, if it changes, it likely it's going to drastically alter the structure of reality. Not always, but likely it's always going to do that. So it doesn't matter what value it takes. You could always argue that it's fine-tuned. So because
especially if you look at hundreds of billions of years of development, you will definitely see that.
Okay, honestly,
values that we observe doesn't mean that the universe was in any way, shape, or form set to, prescribed to, eventually going to have those values. That's the best way to work. Is the way
I think fine-tuning is a pipe dream, actually.
Yeah.
But,
look, reality is it just is that way. There's no reason or meaning as to why. It just is.
Yeah. That's what we're finding here. Yeah.
I mean, I think it depends on what you mean by fine-tuning, though. It means if you mean that there's some kind of relation, that there's some kind of like a relation between structures that form and the values of the fundamental constants, that something like that, sure. I mean, I don't think that's something that can be denied, although that can be trivialized in saying, look, the fundamental constants of nature, like whatever, will form whatever structures that are allowed to form within those universes.
So the problem is that the fine-tuning argument is often used to make the argument that the universe and planet Earth was designed for life. And the fact is the vast majority of planet Earth is inhospitable to life. Go 10 feet underground, you're not going to live. Go to a volcano, you're not going to live. How long can you live in the ocean? Right. Well,
a lot of it too is like the puddle argument, right? I mean, it's a matter of like the perception that's the issue here. It's not that the universe is exceptionally well tuned for us. It's not the fact that this hole is so great for me because I just happen to be able to stretch so much, and it's just the right size, and the water is it's so great, right? Well, what are the chances that that it's a property of the hole being suited for the water in the hole, the pond, or that it's the rain that happened to conform to what was already there?
It's
right?
It's the fallacy of the consequent. That's all it is. They're all using this to argue that God designed it, and it's just another thing that's being offered to prove God. That's what it all boils down to, I find.
The thing that I would say is that if one's going to argue, well, I mean, yeah, I can grant that life is extremely rare in the universe and that it wouldn't survive in most of the universe. Why does it form anyway? I would say, well, that assumes, when you ask that question, you're assuming that life has some precedent to begin with. Can you give me the argument for that? And I've never been given that, other than religiously based arguments that can be as dismissed as easily as they are presented.
I mean, I think the interesting thing is that the net result of life is to increase entropy, right? Is to highly disorganize its environment. And that might be one reason why life happens to form, but it's not a really quantitative explanation of how exactly life happens to form, on this planet or any other planet for that matter. It's it does seem that life is rare, but it also seems that it's exceptionally non-rare, though, either. Because there are...
Okay, I see how it is. I'm waving at you, Brian, but you can't wave back.
I was adjusting my sound so I didn't echo.
I'm sorry, Immutable.
No, it's like the processes to form life seem somewhat ubiquitous. It's just a matter of
exactly
if a certain number of events can occur in the way that, would be required for some of these higher order macro structures to form.
Exactly. I always say that the whole abiogenesis discussion is not, and I would argue that it's never been a discussion of whether life can form through natural processes. Life exists in the natural world. It's constructed of natural material. It operates under natural laws. Obviously, the strong indication, what I would argue is a very reasonable conclusion, is that life develops naturally. The problem is what are the processes, the environments, what have you, that allow for the development of what we call life? And what I would argue is that what we call life are just the chemicals, the chemical reactions, the processes, all of these things involved that are the most stable within the most abundant and the most stable chemicals or processes, reactions, what have you, that can take place within the particular environments that we observe. And that as those environments change, they will change the chemical structure, the chemical of things within these environments, the processes and the functions that they engage in. And that's what we call natural selection on life. Life is fundamentally chemical. The environment changes, you're going to change how the chemistry behaves. It's simple as that.
I came in here to pick a fight with Randolph Richardson because I disagree that that within the Earth that basically most areas of the surface have some form of life at some level.
Oh, I was giving an example in the context of human life. I should have specified that. I apologize.
Yeah.
Thank you for pointing this out and clarifying this. You are correct. You win.
Shortest debate I've ever seen.
Yeah.
We're honest debaters.
Yeah, we are.
Kicked his ass,
we tried to be.
BrainBug.
But that was a very good point that BrainBug made. It's,
I come in swinging.
Different types of life throughout the planet. Yeah, he's right about that.
Yeah.
I
Even
think,
like the thermal vents and stuff, it's amazing where life can flourish.
Well, just today, Speed Immutable and Scott, who's no longer with us in terms of him not being in the stream, he's still alive, went over, a hot springs hypothesis. I only caught, a couple minutes here and there because I was doing some other things. Immutable was the only one talking every time I listened in, which I think is fun. He was always going deep into like some sort of biochemical process or something, how it's just like, just because we don't have definitive answers does not mean that what we're seeing or what we're talking about is somehow far-fetched, and that is a major, I guess you could say, assumption that is made by a lot of those that are a little hardened to abiogenesis.
The unique thing about abiogenesis itself, and particularly about the life that we have currently, is there's certain types of compounds and certain types of bonds that only form under very select types of conditions in a natural setting. And it's one of those things where it's like, okay, well, if you're going to have life, you got to have those reactions. And if you got to have those reactions, it's harder for some of these to occur under one hypothesis, but not so hard under another.
Exactly.
And I think that's what I was kind of trying to get at. But that's kind of what makes the problem a little bit more confined. I mean, you're not dealing like with this giant 10 to the 500 number, because you're dealing with environments that, you understand the behavior of chemicals and their transformations.
I have a question for you, Immutable, real quick, about the stuff that you all were looking at earlier, because I was kind of in and out on it. Were they talking about thermal vents in like the benthic zone, or what level were those vents at that they suspect? Do we know?
I think in the paper itself, it's referencing like subaerial hydrothermal vents. But I could be mistaken on that.
Which paper? The hot spring?
Yeah, I think it's referencing.
They're talking about volcanic springs on land or around volcanoes and springs.
On land?
Yeah. It's not an ocean theory. It's more of a
more of like
wet
a puddle
dry cycle theory.
Yeah, wet dry cycle puddles and
yeah. If you look at David Deamer's video, which I think I linked somewhere, maybe in one of the first papers, he actually goes to one of these hot springs that are bubbling up, like Yellowstone. Think Yellowstone.
Yeah, and you can see the bioactivity. You can see the chemical reactions from the bioactivity in the hot springs now, and some of those life forms in there are endemic and just live in that specific hot spring. It's really interesting.
I think it's a testament to natural selection, which is again a testament to how the environment that particular chemicals and chemical pathways and reactions and processes are subjected to. As the environment changes, the processes can change, will change with it, and they will either cease due to changing in a way that is not beneficial to sustenance within that environment, or they will.
But Brian,
what we call will is the life as we see it today.
Brian, it's about phase boundaries, the boundaries between the spring and dry land. And there's a temperature gradient from, one end to the other. And so it's about wet dry cycles and.
Yeah, I heard parts of that about the wet dry cycles.
Yeah.
I guess a marine biome just seems like it'd be, have the more the minerals that.
Well,
here's the issue with that one, and that is having a lot of minerals and stuff like that can sometimes fuck up certain chemical reactions in terms of like having compounds coagulate together and group together. But the other issue is that like in environments that are too acidic, you just negate certain reactions altogether. And that's one of the fears of dealing with hydrothermal vents, in addition to the fact that peptides are very hard to form. Because peptides, when you react to amino acids, the basic reaction is one of the amines reacts with one of the carboxyl groups and it releases water as a product. Well, here's the thing. If the formation of that reaction favors water as a product, which it does, that's what it does, then that reaction won't go to equilibrium if you have shitloads of water already in the environment. So it has to be in an environment that's dry or somewhat, not populated with water. Because if there's too much water already, well, you're just getting more water to come out, and that's not favored by the environment. If that makes sense.
I'm mulling it over.
Yeah,
because, I'll say, I'll admit it right now, I'm kind of biased towards a marine thermal vent theory, but it's interesting to look at different.
Well, the thing is, Brian, it was very unlikely to be one or the other, but all at once, all of them at once. So I mean, there's a combination of things. But I can't find. Does anybody have a link to Deamer's the video where he went and dumped the flask in the hot spring? I thought I'd put it in one of my videos, but I didn't.
Is that the one we watched like a couple weeks ago?
Yeah, and I can't remember where we watched it.
How do you spell it? It's David Deamer, right?
David Deamer, yeah.
How do you spell Deamer?
Deamer. Deamer, like Beamer. Deamer.
Like Dreamer without an R?
Yeah, there you go.
Do you remember what the video was called?
No, I'm trying to find that. I'll see if I can find it for you.
Do you remember how long it was?
So
I think it was about half an hour long, something like that. Systems biology. Let's see, synthetic life. I think it had a picture.
So is the wet dry cycles providing the environmental pressures for?
So the wet dry cycle is doing one of two things. So number one, it's allowing concentration to occur within.
Yeah, I found it. I found the video.
Oh, you did? Can you link it in chat or somewhere?
Yes, I can. I'm gonna link it in the private chat.
It's doing two things. The first is it's allowing concentration to occur, but it's also changing environments so that certain reactions that do occur in dry environments will occur. And when it becomes wet, some environments that need to occur in wet environments will occur in wet environments. And because it's very easy for the environment to change on scale of times of like minutes to hours, you have a constant procedure of some products forming, concentrating, going back into solution phase, certain solution products forming, concentrating, going back into dry phase, and so on and so forth.
Okay.
If that makes sense.
Check this out. Check this thing out. Hang on a second.
Is that the video in the side chat there, Leo?
Yeah.
That's him pouring a flask of lipids and some amino acids and nucleobases into a hot spring, basically. And let's see, I got the sound turned off. So let's see if I can
turn the sound on before you play it.
Picture. Well, it's a pretty long video, so
Who cares? Turn the fucking sound on.
Well, I'd have to put headphones on, and I'm really tired.
You can just mute yourself.
All the details, I can tell you where to read about it, but what
Can you
was
hear it?
exciting is that we saw white stuff within minutes accumulating around the edge of the pools. And that's where this idea came, that maybe life could begin by the wet-dry cycles. That white stuff is the membranous material that I put in, the amplifiers, soap-like molecules. You could predict that it should form frothy soap, it should form membranes, and it did.
Please
the
mute
idea
yourself.
of the wet-dry cycles came from that.
I can't.
So,
yes, you can.
No, I can't.
I think
Yes, you
that
can.
might be where life began. So we came home and I said, I want to simulate that. And we built.
Why did you pause the video?
Could you hear it while I was muted?
Yes.
I could hear it, yeah.
It's not echoing when you're muted.
A simulation
when
chamber.
you're not
That's what you
muted,
do
it comes through your
in science.
speakers
You
and
can't go to
through-
Kamchatka anytime you want, so you try to bring Kamchatka to you. So I built this chamber, and what you see is a aluminum disc that circles very slowly, about once or twice an hour. It's got these little wells that hold a glass vial with our reaction mixture. It gets dried here and here by a stream of carbon dioxide coming from here, and it gets wet by water coming into here and here from this little pump that pumps in the water. So it's a wet-dry cycle in the laboratory simulation. And of course, we got a heat source. These are two laboratory hot plates. So here is, I'm getting toward the end of my talk now. Here is our experiment. This is unpublished. We haven't dared to try to put this out yet because we have to repeat it. Kind of a complicated experiment to do, but we are in the process. So we put in one of the nucleotides of DNA called thymidine monophosphate, TMP. We put it through wet-dry cycles, and the prediction was that we should see it form a polymer composed completely of TMP, because that's all that's there. It had to work. So the question is, can we make this happen in the laboratory? And here's the evidence. Now, this is the only technical slide I'm going to show you. And you've probably never seen anything like this in your life, but I'll try to explain it to you. So we had a gel and a scan of radioactive oligomers. So if we had made a polymer from that monomer, we should be able to label it with a radioactive phosphate at the end and see that labeled material in what is called a gel. So a gel starts up there at the top. See that band up at the top?
Was there before earlier in this video? Was there that spring he was at? Did they talk about the chemical composition of that?
Yeah, just a few
levels and stuff.
Just at the beginning of it. Let's see, we're at 4336.
Hold on really quick, Speed. James Downard is in the chat. He's talking about the technical paper on this since the talk was given, then he cited it. Is that the same one you guys went over earlier?
Yeah, James, that's the paper that this video is about. We did the section 3, was it? At the very beginning of this. So anyway, let me go back here if I can.
Well, I mean, I was just if it says it, I'll take you. We all have looked.
Oh,
at
no, I want to show you.
Before.
Let me show
I just
you.
wanted to know about because phosphates always.
Okay, right there is where he did it. 4 amino acids, 4 nucleobases. Well, I think he gets a little further into it later on, but we'll go back to where we were.
Okay.
I think he tells you here that he was using.
That's a label that we know some nucleotides select. And everything else, all these other bands you see, are oligomers.
Fuck you, Leo.
Separated by a single nucleotide. So this down here is about 40 nucleotides long, 50, 60, 70, 80, and 90. Nobody else has ever made anything like this so simply. All we did was do 4 wet-dry cycles. Then we labeled it, put it in the gel. Then we put it into a little device called the MinION, which let us sequence the DNA. We attached those monomers, those oligomers, to a known piece of DNA and put it into our little sequencing device. And look what we got. There's the oligo T. We saw that all throughout these polymers that gave that gel pattern. So that one up on top is like a 20-mer, so it's a little off scale here. This next one I was about maybe
Could you
a 40-mer,
possibly make that full
so that
screen?
would be down there. And this is
I don't know if any of you guys are having trouble.
Before we go any further here, the creationists may say, "Oh, that's all thymine, right?" But that's all they put in it. So that's why they only put thymine in it, because they wanted to see if it was actually forming, because the rest of that sequence is a tag they put on it so that they could basically analyze it. So
yeah,
anyway.
Can you make this full screen?
Yeah, I can.
Awesome. Fucking poggers.
Yeah, go fuck
There
yourself.
we go. Oh,
You want it
Maybe
better?
so
yes, I said ope. I'm from the Midwest.
Decrepit.
Oh.
Ope. You say ope too, Speed. I've heard you say it.
about a 60-mer, which would be up there in the gel. So we think that we have made DNA from scratch that is recognized by enzymes that recognize DNA, and this has never seen anything alive. So we will claim that we have made DNA, and furthermore, we can encapsulate it in lipid membranes. There it is. We can watch the DNA in the membrane by staining it with a fluorescent dye. So we're using a very simple lipid mixture of a fatty acid called decanoic acid, and it's a thing called a monoglyceride, which just got a glycerol attached to it. So this is at the start. Here's after 1 cycle, we see a little fluorescence. Here's 2, 3, and 4 cycles. So there's the DNA. We are making DNA from scratch in protocells. We're producing protocells. So that's the main story. So let me just finish up here. Here's our scenario. Wet-dry cycles in volcanic hot springs concentrate mixtures of lipid vesicles and nucleotides in thin films on mineral surfaces. The wet-dry cycles synthesize nucleic acids, and the lipids then encapsulate the polymers. The polymers then are a kind of a natural experiment. Each little microscopic thing is a kind of a natural test tube. It's the Earth trying to find a way to become alive in a sense. So those are natural experiments, and each one is different from all the rest. And we make billions. Every time we do this, we make billions of these things. Finally, and this is where we are now, we have to find a way to see if we can get those to be selected and evolve. We think we know how to do that. We're looking ahead several years, but this is where we are right now. We thought this was such a good idea that we wrote to the, oh yeah, this one last slide here. This just summarizes everything I've told you about. So here we have the solar system. We have the dust coming down, accumulating, and actually I got little signs here that's synthesized on the dust by that UV light, delivered by infall. It accumulates in these volcanic land masses. It's flushed into hydrothermal cycling area, and then we get these protocells I just shown you.
Well, I appreciate
So we
the
thought this was
artistic
such a good idea that we
touch
wrote to
of
the
this
editors.
graphic. People are gonna mock this and think that there's the implication this is all happening in one event. Look at that.
Mm-hmm.
I'm impressed.
Of course they are.
This looks really cool.
Yeah. I hope I don't get a copyright strike for this one, but this is.
You've already shared this on your channel, Speech. You're not going to get copyright struck.
Okay.
And we stop enough. It's
before I go. I was wanting to ask Brian. maybe this is going to be a long conversation than anticipated. What are the reasons, like, you think, like, marine hydrothermal vents are more, well, why do you hold, like, marine hydrothermal?
Well,
Because
I could
Nick Lane.
It'd probably be better for me to just send you the papers that I've read on it than to delve into it right here. But
did you read Nick Lane's book on it?
I'm reading it currently. I'm reading part of it.
Yeah. Anyway, well, all of these things are very provoking, and they all seem to be. They all may be part of the story because there's a lot of shit going on the Earth for those 300 million years, right? And I wouldn't.
I don't disagree. I mean, I think the one issue I have with the hot spring hypothesis is kind of, and I haven't read it all the way through, so maybe this is something they address. But it seems kind of radical to propose that life, first began on land and then evolved to, then for the majority of its history went to sea and then evolved.
What if they were both sources of a different kind of life? Those extremophiles that live now. What if they found the same course?
Well, we know that they're both related to another type of ancestor, right? Like there's a common ancestor between Archaea and Prokarya.
Well, what if they both developed like that independently and found a convergent solution in the protein space? That would be interesting. But
I'm looking for the paper with the phosphate thing on it, because that was the main ingredient that I thought we were missing from terrestrial hydrothermal vents. Is that if that's not a factor in this, then I mean,
yeah, but there was a hell of a lot of phosphorus ore, basically, I think, in prebiotic Earth. So I mean, that was on land too. That was already there, and phosphate chemistry is pretty prevalent and easy to do, I think. So I think there's a possibility of both.
To my knowledge, and I'm not very educated on the marine hydrothermal, but I thought it was hard to get concentrated phosphates in marine hydrothermal.
I think it's more about the state that phosphate is in it.
It's fixating phosphorus.
Yeah. So
to be in the right state.
I guess I see cells developing on the phosphorus like that. But again, I don't know the phosphate levels of these ones that we're talking about. The wet dry cycle flow. I get why we're looking at that and thinking that's definitely a factor. And I do think if anything, that's providing environmental pressures for the new formations to change. I guess forcing change on it. I don't know. I'll have to look for that. It was in regards to the phosphate though. That was my main.
Okay, well that's it. That's a good reason. I mean, I think I've seen like a few papers from like Benner and stuff like that, kind of dealing with kind of going with that type of issue about how do you with geologic chemistry, like how is it that we get fixed like phosphate compounds and stuff like that?
Well, the other interesting thing is the bit about the moon being much closer and the tides being so high that they probably would have splashed up against the Rockies. So I mean, there was a lot of ocean water landing on coming onto the land, and draining down. I mean, it's just like a big mix master of, different environments. Yeah. I like what he said about the millions of little test tubes that exist in any one hot spring, all these experiments. And when you think about abiogenesis research, how long will it take us to figure out each of what's happened in each of those test tubes? I mean,
the thing is, we don't need to know.
Yeah, well, we need to find a path, and that's what we're looking for. We're looking for that path. We're looking for that connection through that network diagram of life. But I mean, there's so many possibilities that you almost want to say that life had to form, that it had to happen. because the combinations are astronomical.
Yeah, it had to form, and it had to form in such a way that it would have been able to evolve with its environment, right?
Yeah.
It had to evolve in a way that it could manipulate its environment and develop like the molecular machinery it has, or prototypes of that to kind of survive and to what the paper was saying, kind of to make more of itself. And that seems, I don't know, to me that seems more preferable in
But wait a minute.
not so turbulent as a like hydrothermal, like marine hydrothermal.
Look at that cloud coming out of the volcano. Do you see those two eyes there and the trunk sticking into the volcano?
Yeah.
Those two eyes? That looks, I think that could be the spaghetti monster, could it?
It could. I don't know.
Dipping
dipping
his trunk into the volcano and sucking out life.
There we go.
Yeah. Solved it. Fixed it.
Yeah.
Is it time to go to bed, guys? Time to go watch TV? Maybe eat some food?
I think it's time we go.
Yeah. What do we got to pay to get out of here?
Goodbye, Cruel World.
Oh, that's it. Anybody have anything to say? Randolph, you got anything to say before we go? He's preparing to unmute.
Yeah, sure. I've got the first board in for the framing. I only have 3 concrete screws in so far, but I'll be putting the others in tonight. I like to put extras in. So
before the wind comes,
I'm going to put a lot more in. So we have a styrofoam barrier between the wood and the concrete so that we won't end up with a whole bunch of moisture problems, because that is a problem, and that's how we solve it here in construction. So
cool.
Yeah, it's hard work drilling holes into the cement, but I don't know if you could see it. I've got a really good drill for that, and hammer drill, so it does the job quite well. So yeah, I'll just show this again there. It's a little hard to see, but some people are following what I've been doing here. So if you want to put me full screen, you can sort of get a view of it there.
See if I can make you.
Hi, BrainBug.
There you are, BrainBug.
Hi, BrainBug.
I'm working on it, guys. Oh, there it is.
Yeah, so that piece of wood across the bottom, that's in there solid. That's like part of the cement. It feels like there's no wiggle room, there's no play, nothing.
Right.
It's in there solid like it's supposed to be. And the concrete screws are very important. That's the hammer drill sitting there next to my ear protection and eye protection. And so, yeah, I always blast it out with the compressed air after drilling it so that I can get the best grab with the concrete screw.
So this being your YouTube studio, this is like the ultimate pre-show. We have to get to see the studio coming together, right?
Yeah, we're not taking calls yet, but once it's up and running, we will be. And I've got some plans for setting up lighting and things like that as well. I'm starting to research that in the audio system and whatnot. So that's I'm enjoying this. It's a lot of fun. Neil comes and helps me a lot. And anybody wants to know more about that show, it's we've got the website already set up. It's at www.truenorthtalk.ca. There's a link to the YouTube channel there. You can see Neil and I working on some stuff. It's some of those videos are a lot of fun. It's Neil adds so much humor to it. It's great. I'm other thing that I'm working on is I've started a campaign recently to normalize atheism. And what I mean by that, and you can find out more about it at www.normalizeatheism.ca. And what this campaign is about is, well, where religious people, when they tell people they're religious, that they believe in a deity or something, or deities, generally in society that's accepted without a problem. And when people say we don't believe in deities, that sometimes gets a response of shock and surprise and concern and worry that we're going to hell and things like that. It's like we're being ostracized for it. So what we're asking for with this campaign is to be treated the same as the theists, to have the same courtesy. And I think this is a very reasonable thing to ask for. So this is what we're trying to promote. And we're trying to do it in a very gentle, kind of non-confrontational approach. This is part of the Canadian Atheists mandate to try to see it normalized in Canadian society and hopefully catching on around the world. And you can find out more about Canadian Atheists at www.canadianatheists.ca. Thank you very much for having me on. This was a very interesting topic. You guys got into some really high technical information there, and you even had one short debate, and BrainBug won. So congratulations again to BrainBug.
Okay, thanks.
Thanks.
Okay, Leo and Brian, you got anything, Brian, you want to talk about?
I'll just wave while they talk.
Okay. Got anything, Brian, Leo, anybody, or can I say goodbye?
I'm still full screen, by the way.
Oh, yeah, okay. Well, we like you full screen, man.
Yeah, but...
I had my vivarium build today, released on my channel. If you like that kind of stuff, it's just making a vivarium for my Venus flytrap. So,
cool.
Ooh.
I'll check that.
Yeah.
Okay, Leo, you got an eigen state coming up, right? No?
Leo.
Can you hear us, Leo?
Leo.
Oh, screw him. Okay, we're ending the stream.
You must be on,
Leo.
you must be on Amelia Clark's Twitter or something.
Yeah, he's listening to something else.
Leo.
Anyway, I'm gonna end.
Leo.
We don't need him. He'll just go on for another half an hour. So, okay, goodbye, everybody out there. Thanks for watching. Goodbye, cruel world.